Question 1. Calculate mole fractions of urea and water if 2 gram of urea is dissolved in 31.4 gram of aqueous solution. Weight of urea given है 2 gram. Molecular weight of urea होता है 60 gram per mole. Weight of water given है 31.4 gram. First of all, we will find out moles of urea. तो moles of urea हो गया weight of urea divided by molecular weight of urea. And this is equal to 0.033 moles. Now moles of water is equal to weight of water divided by molecular weight of water, and this is equal to 1.744 moles. Now total number of moles होगा moles of water plus moles of urea, and this is equal to 1.777 moles. Now mole fraction of urea will be equal to moles of urea divided by total number of moles, and this is equal to 0.02. Now in this solution there is one solute and one solvent, so mole fraction of solute or mole fraction of urea plus mole fraction of solvent, that is mole fraction of water, is equal to 1. अब mole fraction of urea, now we know the mole fraction of urea, that is 0.02. So mole fraction of water will be equal to 1 minus 0.02, which is equal to 0.98. Question 2. Under what condition will the molality of a solute not be equal to its molarity? Now formula for molarity is moles of solute divided by volume of solution in liters, and molality is equal to moles of solute divided by mass of solvent in kg. Now if we consider that the amount of solute dissolved in solvent is very less, then usually the volume of solution is equal to the volume of solvent taken. But for mass of solvent will be equal to volume of solvent into density of solvent. So if the density of solvent is high, in that case mass of solvent will increase, and in such cases molality will not be equal to molarity. Question 3. A sugar syrup of weight 214.2 gram contains 34.2 gram of sugar. Molecular formula of sugar is C12H22O11. Calculate first molar concentration and second mole fraction of sugar in the syrup. Sugar syrup और solution of sugar in water, उसका weight given है, sugar का weight given है, sugar is the solute, water is the solvent. Now we have to calculate molar concentration. Molar concentration means molality of the solution, और molality of the solution का formula है moles of solute divided by mass of solvent in kg. Now moles of solute के लिए we need to know weight of solute and molecular weight of solute. So molecular weight of solute, that is sugar, is 342 grams per mole, and weight of solute is given as 34.2 grams. So moles of solute or moles of sugar will be 34.2 divided by 342, which is equal to 0.1 moles. Now mass of solvent in kgs, उसके लिए first of all the weight of solution is given as 214.2 gram. Weight of solute or sugar is given as 34.2 gram. So weight of solvent, that is water, will be equal to weight of solution minus weight of solute, that is 214.2 minus 34.2, and this is equal to 180 gram. So weight of solvent, that is water, is 180 gram. Now we need the mass of solvent in kgs. So 180 gram को kg में convert करेंगे, so it becomes 180 divided by 1000 kg. So molality of the solution will be moles of sugar divided by mass of water in kg, and this is equal to 0.556. Second part of the question, mole fraction of sugar in the syrup. So mole fraction of sugar in the syrup, the formula will be moles of sugar divided by total moles. Now total moles is equal to moles of sugar plus moles of water. So moles of water will be equal to weight of water divided by molecular weight of water, and this is equal to 10 moles. So mole fraction of sugar is equal to moles of sugar, that is 0.1 divided by total moles. Total moles कितना हो जाएगा? Total moles होगा moles of sugar, that is 0.1 plus moles of water, that is 10, and this is equal to 10.1. So 0.1 divided by 10.1, and this is equal to 0.0099. Question 4. Calculate mole fraction of solute in an aqueous 4m solution assuming the density of the solution as 1 gram per milliliter. Small m means molality. So molality of the solution is 4 और molality का formula है moles of solute divided by mass of solvent in kg. So moles of solute को अगर हम mass of solvent से divide कर देंगे, what we get is moles of solute per kg of solvent. So if the molality of the solution is 4m, then we can say that 1 kg of solvent contains 4 moles of the solute. So the weight of the solvent will be 1 kg. इसको convert कर देंगे grams में, that is 1000 grams. And moles of solute present in 1 kg of solvent is 4. Now the solvent is water. So moles of solvent is equal to weight divided by molecular weight of water, that is 1000 divided by 18, and this is equal to 55.56 moles. Now mole fraction of solute is equal to moles of solute divided by total number of moles. So moles of solute है 4 moles. Total moles हो जाएगा moles of solute plus moles of solvent, or moles of solvent plus moles of solute, that is 55.56 plus 4, and it is equal to 59.56. So 4 divided by 59.56 gives the mole fraction of solute, and this is equal to 0.0672. Question 5. Nitric acid 70% has a specific gravity of 1.42. Find the normality and molarity of the acid. Now first of all normality का formula. Normality का formula होता है equivalence of solute divided by volume of solution in liters. This is normality. Or equivalence of solute will be equal to weight divided by equivalent weight of the solute. Now this 70% is the weight percentage. So if weight of HNO3 is 70 gram, then weight of solution is 100 gram. अब weight of solution पता है. How do we find the volume of solution? So volume of solution will be equal to mass by volume is equal to density. So volume will be equal to mass divided by density, which is equal to 100 divided by 1.42. So we know the volume of solution. Now we have to convert this volume into liters. So volume of solution in liters will be volume of solution, that is 100 by 1.42, and to convert it into liters we will divide it by 1000, and volume of solution becomes 1 divided by 1.42 into 10. Now number of equivalents of HNO3. Number of equivalents of HNO3 will be equal to 70 divided by 63. So normality of HNO3 solution will be equivalents of HNO3 divided by volume of solution in liters, and this is equal to 15.8 N. Now molarity. Molarity का क्या फॉर्मूला होता है? Molarity का फॉर्मूला होता है moles of solute divided by volume of solution in liters. So volume of solution in liters, we know it is 1 divided by 1.42 into 10. Moles of HNO3 will be equal to weight divided by molecular weight. So putting the values and solving, molarity of HNO3 is equal to 15.8 m. Number of equivalents of HNO3 will be equal to weight of HNO3, which is given as 70, divided by equivalent weight of HNO3, that is 63. Now equivalent weight of HNO3 is equal to its molecular weight, and this is equal to 63. Question 6. 1 gram of NaCl is dissolved in 10 gram of a solution, the density of which is 1.07 gram per centimeter cube. Find the molality and molarity of NaCl. Formula for molality is equal to moles of solute divided by weight of solvent in kg. Now weight of solute is given as 1 gram and the solute is sodium chloride. सोडियम क्लोराइड का मॉलिक्यूलर वेट है 58.5. सो मोल्स ऑफ सल्यूट इज इक्वल टू वेट ऑफ सल्यूट दैट इज 1 ग्राम डिवाइडेड बाय मॉलिक्यूलर वेट ऑफ द सल्यूट दैट इज 58.5 डिवाइडेड बाय वेट ऑफ सॉल्वेंट इन केजीज. नाउ वेट ऑफ सॉल्वेंट कितना होगा? वेट ऑफ सोल्यूशन गिवन है 10 ग्राम, वेट ऑफ सल्यूट है 1 ग्राम. सो 10 minus 1 that is weight of solution minus weight of solute will give the weight of solvent, which is equal to 9 gram. Now weight of solvent in kgs will be equal to 9 divided by 1000. So putting the values in the formula for molality, that is moles of solute divided by weight of solvent in kgs, is equal to 1.899. This is the value for molality. Now formula for molarity. Molarity is equal to moles of solute divided by volume of solution in liters. So moles of solute will be equal to weight of solute, that is 1, divided by molecular weight of solute, that is 58.5, divided by volume of solution in liters. Volume of solution will be equal to weight divided by density. This will give the volume of solution. अब density की value है gram per centimeter cube में, so volume of solution will be in milliliters when we divide weight by density. To convert the volume into liters, the volume of solution in liters will be 10 divided by 1.07 into 1000. This will give the volume of solution in liters. So volume of solution in milliliters, that is 10 divided by 1.07, and this when divided by 1000 gives the volume of solution in liters. This is the number of moles divided by volume of solution in liters, and this gives the molarity of the solution. So putting the values, molarity is equal to 1 into 1.07 into 1000 divided by 58.5 into 10, and this is equal to 1.829. So molarity of the solution is 1.829. This will be here into 1 by 1000. Question 7. Calculate mole fraction, molarity and molality of C2H5OH solution which is 50% by weight of C2H5OH in H2O and has a density of 0.9144 gram per centimeter cube. Molecular weight of C2H5OH is 46. Now weight percent is given, that is 50%, which means weight of solute, that is weight of C2H5OH is 50 gram and weight of solution is 100 gram. So weight of solvent will be equal to weight of solution, that is 100, minus weight of solute, that is 50, and this is equal to 50 gram. So weight of solvent is 50 gram. Now formula for molarity is moles of solute divided by volume of solution in liters. So moles of solute will be equal to weight of solute divided by molecular weight of solute, that is 50 divided by 46, and volume of solution in liters will be equal to volume of solution will be equal to weight of solution, that is 100, divided by density of solution, that is 0.9144 gram per centimeter cube. Now this volume is in milliliters, so we will have to convert it into liters. So this is equal to 100 divided by 0.9144 into 1000. This will give the volume in liters. Now putting the value of volume of solution in liters in the formula for molarity and solving, the value of molarity is 9.939. Now next is molality. Again, the formula for molality is moles of solute divided by weight of solvent in kgs. So moles of solute is 50 divided by 46 and divided by weight of solvent in kgs. Weight of solvent is 50 grams and its weight in kgs will be 50 divided by 1000. So putting the values in the formula for molality, the value of molality is 21.7. Now mole fraction of C2H5OH. Now moles of C2H5OH is 50 divided by 46, that is weight divided by molecular weight, and this is equal to 1.09 moles. Moles of water is 50 divided by 18, that is weight divided by molecular weight of water, and this is equal to 2.78 moles. Now total number of moles will be moles of C2H5OH plus moles of water. So total number of moles will be 3.87 moles. So mole fraction of C2H5OH will be equal to moles of C2H5OH, which is equal to 1.09, divided by total number of moles, which is equal to 3.87, and mole fraction of C2H5OH will be equal to 0.281. This here will be into 1 by 1000. Question 8. The molarity and molality of a solution are capital M and small m respectively. If the molecular weight of the solute is m dash, calculate the density of the solution in terms of capital M, small m and m dash. Formula for molarity क्या है? Formula for molarity है moles of solute divided by volume of solution in liters. So अगर volume of solution milliliters में given है, तो formula becomes moles of solute divided by volume of solution into 1000. Now, volume of solution can be written as weight of solution divided by density of solution. So यहाँ पे volume of solution की जगह हम लिख देंगे weight of solution divided by density of solution. Now, weight of solution can be written as weight of solute plus weight of solvent. Now, multiplying and dividing this whole equation by weight of solvent, we will get moles of solute divided by weight of solvent in the numerator, and in the denominator we get weight of solute divided by weight of solvent, और यहाँ पे weight of solvent divided by weight of solvent हो जाएगा 1. This whole equation multiplying it by weight of solvent and dividing it by weight of solvent. We get this equation. कैसे? ये जो डिनोमिनेटर में weight of solvent है वो हो जाएगा n divided by weight of solvent, this one. और ये जो न्यूमरेटर में weight of solvent है, this is nothing, this we can write as, ये जो पूरा weight of solute plus weight of solvent है, ये पूरा ही weight of solvent से divide हो जाएगा. So यहाँ हमें मिल जाएगा weight of solute divided by weight of solvent plus 1. Now moles of solute divided by weight of solvent into 1000, this gives molality. So n divided by weight of solvent into 1000, this whole becomes equal to molality. So we can write this as small m into d, and in the denominator weight of solute can be written as moles of solute into molecular weight of solute, and dividing it by weight of solvent, this whole comes into the bracket plus 1. Now ये जो bracket में equation है, इसको अगर multiply and divide कर दें 1000 से, that is n into m dash divided by weight of solvent. So if we multiply and divide this by 1000, that is into 1000 and divided by 1000, then number of moles of solute divided by weight of solvent, this is in grams, and this weight of solvent when it is divided by 1000 will give the weight of solvent in kgs. So n divided by weight of solvent and this 1000, this will give again the molality, and the remaining is molecular weight of the solute divided by 1000. So this bracket, it becomes m into m dash divided by 1000. So now we get the equation molarity is equal to molality into density divided by molality into molecular weight divided by 1000 plus 1. Now rearranging, we get density is equal to molarity into molecular weight divided by 1000 plus 1 divided by m. Now further solving this, we get density is equal to molarity and in bracket molecular weight divided by 1000 plus 1 by molality. ये जो इक्वेशन है इसको अगर फर्दर सॉल्व करेंगे, दैट इज m, और ये ब्रैकेट में है molality into m dash divided by 1000, and this whole is divided by molality. So denominator में आ जाएगा molality plus 1 by m. Now m gets cancelled and we get this equation, that is molarity and in bracket molecular weight divided by 1000 plus 1 by molality. Question 9. When 400 gram of a 20% solution was cooled, 50 gram of the solute precipitated. What is the percent concentration of the remaining solution? 20% solution means 20% को हम कैसे लिख सकते हैं? 20 divided by 100. तो न्यूमरेटर में है weight of the solute और डिनोमिनेटर में है weight of the solution. So if 100 gram of solution contains 20 gram of solute, then 400 gram of solution will contain 20 divided by 100 into 400, that is 80 gram of solute. Now, when this 400 gram of solution containing 80 gram of dissolved solute is cooled, then what happens? Then 50 gram of the solute precipitated. So, out of 80 gram of solute which was dissolved in the solvent, to give 400 gram of solution, 50 gram of solute precipitated. So now the weight of solute and the solution will decrease by 50 grams. So remaining solute in the solution is 80 minus 50, that is 30 gram. And now the weight of solution will be 400 minus 50, that is 350 gram. So percentage concentration of the remaining solution will be weight of solute, that is 30 gram, divided by weight of solution, that is 350 gram, into 100, and this is equal to 8.6%. Another way to calculate the weight of solute and weight of solution, the new weight, initially weight of solution is 400 gram. Weight of solute is 80 gram. So weight of solvent is equal to 400 minus 80, and this is equal to 320 gram. Now after precipitation, 50 gram of solute is precipitated. तो 80 ग्राम में से 50 ग्राम सल्यूट प्रेसिपिटेट हो गया, सो रिमेनिंग सल्यूट हो गया 80 minus 50, that is 30 gram. Now in this solvent, that is 320 gram of solvent, amount of solute present is 30 gram. So the new weight of solution is weight of solvent, that is 320, plus weight of the remaining solute, that is 30, and this is equal to 350 gram. And to find the percentage of the remaining solution, 30 divided by 350 into 100, and this is equal to 8.6%. Question 10. In what mass of water must 25 gram of copper sulfate, now this is hydrated copper sulfate, be dissolved to obtain an 8% solution of copper sulfate? Now this one is anhydrous copper sulfate. The molecular weight of hydrated copper sulfate is 249.5 gram, and the molecular weight of anhydrous copper sulfate is 159.5 gram. So we can write कि 249.5 gram of hydrated copper sulfate contains 159.5 gram of copper sulfate. Therefore 25 gram of hydrated copper sulfate will contain 159.5 divided by 249.5 into 25, and this is equal to 15.98 gram of anhydrous copper sulfate. Now in the question they have asked that what mass of water must 25 gram of hydrated copper sulfate be dissolved to obtain 8% solution of anhydrous copper sulfate. Now the weight of hydrated copper sulfate that has to be dissolved is 25 gram, which contains 15.98 gram of anhydrous copper sulfate. So let us assume the weight of solution be x gram, and the mass percent of solution according to the question is 8%. So we can write weight of solute, that is 15.98, that is the mass of anhydrous copper sulfate, divided by weight of solution, that is x gram, into 100 is equal to 8. And if this is rearranged, we get 8 by 100 into x is equal to 15.98, and solving we get value of x is equal to 199.75 gram. Now this 199.75 gram of the solution contains 15.98 gram of anhydrous copper sulfate, but it is prepared by dissolving 25 gram of hydrated copper sulfate in water in the solvent. So to get the weight of the solvent or weight of water from the weight of the solution, we have to subtract the weight of the solute, that is 25 gram, to get the weight of the solvent or weight of water, that is equal to 174.75 gram. So this 25 gram of hydrated copper sulfate, which contains 15.98 gram of anhydrous copper sulfate, when dissolved in 174.75 gram of water, will give 8% solution of anhydrous copper sulfate. Question 11. 1 liter of water was added to 500 milliliter of 32% HNO3 of density 1.20 gram per milliliter. What is the percent concentration of HNO3 in the solution obtained? अब 32% HNO3 का क्या मतलब है? 32% HNO3, this can be written as 32 divided by 100. Means if weight of HNO3 is 32 gram, weight of the solution is 100 gram. So 100 gram of solution contains 32 gram of HNO3. अब इस weight of solution को convert कर देंगे volume of solution में. For that, divide mass of the solution by density, that is 100 divided by 1.20. So this is the volume of solution. So 100 divided by 1.20 milliliter of solution contains 32 gram of HNO3. Therefore, 500 ml of solution will contain 32 divided by 100 into 1.20 into 500, and this is equal to 192 gram of HNO3. Now, this is the weight of HNO3 present in 500 ml of solution. Now, when 1 liter of water is added to this solution, now water is the solvent, and 1 liter of water means 1000 milliliter of water. So total volume of the solution becomes, initially volume was 500 milliliter, to this 1000 milliliter of water is added. So the new volume of the solution becomes 1500 milliliters. Now the volume of solution is 1500 milliliters. So this 1500 milliliter of the solution contains 192 gram of HNO3. Therefore, weight by volume percentage of this solution will be weight of HNO3, that is 192 gram, which is now present in 1500 milliliter of solution. So 192 divided by 1500 into 100, and this is the weight by volume percentage of this solution, which is equal to 12.8%. Question 12. Determine the percent concentration of a solution obtained by mixing 300 gram of a 25% and 400 gram of a 40% solution. Now in this question, they have asked what will be the percent concentration of a solution which is obtained by mixing 300 gram of a 25% and 400 gram of a 40% solution. So percent concentration will be equal to, this is for the final solution, weight of solute in the final solution divided by weight of solution, weight of the final solution. Now the final solution is obtained by mixing two solutions, one of which is 300 gram and another one is 400 gram. So total weight कितना हो जाएगा? Total weight हो जाएगा 300 plus 400, which is equal to 700 gram. So weight of solute divided by weight of solution, the final solution that is obtained, that is 700 into 100. This will give the percentage concentration of the final solution. But now we need to find out weight of solute. अब weight of solute कैसे find out करेंगे? फाइनल सोल्यूशन में। फर्स्ट ऑफ ऑल वेट ऑफ सोल्यूट इन द सोल्यूशन हैविंग वेट 300 ग्राम। नाउ इसका परसेंटेज कंसंट्रेशन है 25%, मींस 100 ग्राम सोल्यूशन में वेट ऑफ सोल्यूट है 25 ग्राम। सो 300 ग्राम सोल्यूशन में वेट ऑफ सोल्यूट है 25 divided by 100 into 300 and this is equal to 75 ग्राम। सिमिलरली जो सेकेंड सोल्यूशन है उसका परसेंटेज कंसंट्रेशन है 40% और उसका वेट है 400 ग्राम। सो सेकेंड सोल्यूशन में 100 ग्राम ऑफ सोल्यूशन contains 40 gram of solute. Therefore 400 gram of solution will contain 40 divided by 100 into 400 and this is equal to 160 gram. Let this be solution number 1 and this solution number 2. Now weight of solute in solution 1 is 75 gram and weight of solute in solution 2 is 160 gram. Now when these two solutions are mixed, the total weight of solute is equal to 75 plus 160 and this is equal to 235 gram. Now putting the value of the weight of solute in this formula, we get the percentage concentration of the final solution. So percentage concentration of the final solution is equal to 235 divided by 700 into 100 and this is equal to 33.6%. Question 13. Calculate the percent concentration of a 9.28 N NaOH solution of density 1.31 gram per milliliter. Normality of NaOH given है 9.28 N. Now what is the meaning of 9.28 N? 9.28 N को हम ऐसे भी लिख सकते हैं 9.28 equivalents of NaOH per liter of solution. Now what is equivalents of NaOH? Equivalents of NaOH क्या होगा? It will be equal to weight divided by equivalent weight of NaOH. Weight divided by equivalent weight of NaOH. अब equivalent weight of NaOH कितना होता है? Equivalent weight of NaOH is equal to its molecular weight. That is, equivalent weight of NaOH is equal to 40. So equivalence of NaOH is given, that is 9.28. Equivalent weight of NaOH we know, that is 40. तो हम लिख सकते हैं 9.28 is equal to weight of NaOH divided by 40. Now from this, weight of NaOH is equal to 9.28 into 40. Therefore NaOH का जो weight है solution में, that is 9.28 into 40 grams per liter of solution. तो हम लिख सकते हैं कि weight of solute, that is NaOH in the solution is 9.28 into 40 grams. अब volume of solution given है, that is volume of solution क्या given है? 1 liter. Now 1 liter कितना होता है? 1 liter is equal to 1000 milliliter. और density of solution given है 1.31 gram per milliliter. So weight of solution कितना हो जाएगा? Weight of solution हो जाएगा volume into density. So weight of solution is equal to volume of solution, that is 1000 milliliter, into density of solution, that is 1.31 gram per milliliter. अच्छा, हमने volume को लीटर से मिलीलीटर में क्यों कन्वर्ट किया? Because density is given in 1.31 gram per milliliter. जो density given है वहाँ जो unit है volume की वो milliliter है. So we have to convert the volume into milliliters. So volume, that is 1000 into density, that is 1.31 gram per milliliter. is equal to weight of the solution, that is 1310 gram. Now we know the weight of solute, we know the weight of solution. So percentage concentration of the solution will be equal to weight of solute divided by weight of solution into 100, and this is equal to 28.3%. Question 14. The pressure of the water vapor of a solution containing a non-volatile solute is 2% below that of the vapor of pure water. Determine the molality of the solution. Now percentage decrease in the vapor pressure is given as 2%. Now how to find out the percentage decrease in vapor pressure? Percentage decrease in the vapor pressure can be written as pressure of pure solvent, that is P naught, minus pressure of solution, let it be P, divided by pressure of pure solvent, that is P naught, into 100, and this gives the percentage decrease in the vapor pressure. According to the question, the percentage decrease is 2%. So P naught minus P divided by P naught into 100 is equal to 2. Rearranging, we can write this as P naught minus P divided by P naught is equal to 2 by 100. Now in this question, since the solvent is water, P naught represents the vapor pressure of pure water. P represents the vapor pressure of solution. Now P naught minus P divided by P naught is also known as relative lowering of vapor pressure. Now relative lowering of vapor pressure is also equal to mole fraction of solute. Now mole fraction of solute can be written as moles of solute divided by total number of moles. Now total number of moles will be equal to moles of solute plus moles of solvent. Here small n denotes the moles of solute and capital N denotes the moles of solvent. Now from equation 1 and equation 2, we can write 2 by 100 is equal to n divided by n plus n. Now from this equation, we can write moles of solute is equal to 2 moles, moles of solute plus moles of solvent, that is water, which is denoted by capital N, is equal to 100. Putting the value of moles of solute and solving, moles of water is equal to 100 minus 2, and this is equal to 98 moles. अब मोलालिटी का फॉर्मूला होता है moles of solute divided by weight of solvent in kgs. So we need to find out the weight of solvent, which in this case is water. Now moles of water, that is capital N, is equal to weight of water divided by molecular weight of water, that is 18. Now moles of water is equal to 98. Rearranging and solving, weight of water is equal to 98 into 18 grams. Now this weight of water is in grams. So weight of water in kgs will be equal to 98 into 18 divided by 1000 kg. Now putting the values in the formula for molality, molality is equal to moles of solute, that is 2, divided by weight of water in kgs, and solving, the molality of the solution is 1.134 m. Question 15. What is the vapor pressure at 100 degrees centigrade of a solution containing 15.6 gram of water and 1.68 gram of sucrose? Molecular formula of sucrose is given as C12H22O11. अब वेपर प्रेशर फाइंड आउट करना है. फर्स्ट ऑफ ऑल मॉलिक्यूलर वेट ऑफ सुक्रोज फाइंड आउट करेंगे. मॉलिक्यूलर वेट ऑफ सुक्रोज होगा C12, सो एटॉमिक वेट ऑफ कार्बन, सो 12 into atomic weight of carbon, that is 12, plus H22. So 22 atoms of hydrogen. So atomic weight of hydrogen, that is 1 into 22, plus atomic weight of oxygen, that is 16 into 11. Solving, the molecular weight of sucrose is 342 grams per mole. ये तो हो गया molecular weight of sucrose. Now from this moles of sucrose. Moles of sucrose होगा weight of sucrose, that is 1.68, divided by molecular weight of sucrose, that is 342, and this is equal to 0.005 moles. अब sucrose का solution prepare किया गया है water में. So we will find out moles of water also. Moles of water is denoted by capital N, and this is equal to weight of water as given in the question, that is 15.6 gram, divided by molecular weight of water, that is 18, and this is equal to 0.87 moles. Now we know the formula that relative lowering of vapor pressure is equal to mole fraction of solute. अब relative lowering of vapor pressure क्या है? Relative lowering of vapor pressure है vapor pressure of pure solvent minus vapor pressure of solution divided by vapor pressure of pure solvent, and this is equal to moles of solute divided by moles of solute plus moles of solvent. Now at 100 degrees centigrade, the vapor pressure of water is same as the atmospheric pressure. Now atmospheric pressure is equal to 760 millimeters of mercury, and in centimeters it is 76 centimeter. Now putting the values and solving, 76 minus vapor pressure of solution divided by 76 is equal to moles of solute divided by total number of moles. Solving this equation, the vapor pressure of solution is equal to 75.57 centimeter. Question 16. The vapor pressure of an aqueous solution of cane sugar, molecular weight 342, is 756 millimeter at 100 degrees centigrade. How many grams of sugar are present per 1000 gram of water? Now the formula applied in this question will be P naught minus P divided by P naught, which is equal to N divided by N plus N. P naught is the vapor pressure of pure solvent. Now here the solvent is water, and the vapor pressure of water at 100 degrees centigrade will be 760 millimeter of mercury. So P naught will be equal to 760 millimeter of mercury. Now vapor pressure of the solution. Vapor pressure of the solution is given in the question as 756 millimeter. So P will be equal to 756 millimeter. Now small n denotes the moles of solute. Now moles of solute will be weight of solute. Weight of solute is not given in the question. They have asked for the weight of solute. So let it be W, and moles of solute will be weight of solute divided by molecular weight of solute, that is 342 grams per mole. So value of N is equal to W divided by 342. Now capital N denotes the moles of solvent. Now moles of solvent is equal to, it is given in the question that the weight of water is 1000 gram. So moles of water which is acting as the solvent is weight, that is 1000 gram divided by molecular weight of water, that is 18 gram per mole. Now solving, weight of the solute, that is cane sugar, is 100.5 gram. Question 17. At 20 degrees centigrade, the vapor pressure of ether is 442 millimeter of mercury. When 6.1 gram of a substance is dissolved in 50 gram of ether, molecular weight 74, the vapor pressure falls to 410 millimeter of mercury. What is the molecular weight of the substance? The formula used in this question will be P naught minus P divided by P naught is equal to mole fraction of solute. Now mole fraction of solute is moles of solute divided by total number of moles, that is moles of solute plus moles of solvent. Now P naught is given in the question, that is vapor pressure of the pure solvent. Here the solvent is ether. The vapor pressure of pure solvent is 442 millimeter of mercury and the vapor pressure falls to 410 millimeter when the solute is dissolved in it. So vapor pressure of the solution is 410 millimeter of mercury. Now let the molecular weight of the substance which is dissolved in ether be m. Therefore number of moles of the solute is equal to weight of solute, that is 6.1 gram, divided by molecular weight of the solute, let it be m. Now moles of solvent, that is capital N, is equal to weight of solvent which is given in the question as 50 gram, divided by molecular weight of solvent, that is 74. 74 is the molecular weight of ether. Now putting the values in the formula and solving, the molecular weight of the substance dissolved in ether is 115.7 gram per mole. Question 18. 0.5 gram of a non-volatile organic compound, molecular weight 65, is dissolved in 100 ml of CCl4. If the vapor pressure of pure CCl4 is 143 millimeter, what would be the vapor pressure of the solution? Density of CCl4 solution is 1.58 gram per centimeter cube. Now the solvent here is carbon tetrachloride. Volume of carbon tetrachloride is given as 100 milliliter and its density is also given. So we can find the weight of the solvent or weight of carbon tetrachloride as volume into density, which is equal to 100 into 1.58 and this is equal to 158 gram. So this is the weight of the solvent. Formula used in this question will be vapor pressure of pure solvent, that is P naught, minus vapor pressure of solution, that is P, divided by vapor pressure of pure solvent, and this is equal to mole fraction of solute. Now moles of solute is equal to weight of solute, which is given in the question as 0.5 gram, divided by molecular weight of solute, that is 65, and moles of solvent denoted by capital N is equal to weight of solvent, which is 158 gram, divided by molecular weight of solvent. Now molecular weight of carbon tetrachloride is 142. So 158 divided by 142 gives the moles of carbon tetrachloride. Now putting the values in the formula and solving, the vapor pressure of solution is equal to 142 millimeter of mercury. Question 19. Which of the following aqueous solutions has a higher vapor pressure if the density of water is 1 gram per centimeter cube? A. Solution having mole fraction of cane sugar equals to 0.1. B. Solution having molar concentration equal to 1 m. Now, this is aqueous solution of cane sugar. So, solute is cane sugar and the solvent is water. Now we know that relative lowering of vapor pressure, that is P naught minus P divided by P naught. P naught represents the vapor pressure of pure solvent. P represents the vapor pressure of solution and this is equal to mole fraction of solute. Mole fraction of solute is moles of solute represented by small n divided by total number of moles. Total number of moles will be moles of solute, that is small n, plus moles of solvent, which is denoted by capital N. Now, in the part A of the question, the mole fraction of solute is given as 0.1. So, the value of mole fraction, that is n divided by n plus n, is given as 0.1 and this is also equal to relative lowering of vapor pressure. So, we can write P naught minus P divided by P naught is equal to 0.1. And on solving we get P is equal to 0.9 into P naught. That is, vapor pressure of solution is equal to 0.9 times the vapor pressure of the solvent. Now B part. Here the molar concentration of the solution is given and it is equal to 1 m. Or we can say that molality is equal to 1 m. Now what is the meaning of molar concentration equals to 1 m? It means that it contains 1 mole of solute per kg of solvent. Means moles of solute is 1 and the weight of solvent is 1 kg. So weight of solvent in grams will be 1000 gram. And here the solvent is water. So weight of water is equal to 1000 gram. Therefore, moles of water will be equal to weight of water divided by molecular weight of water, and this is equal to 55.56 moles. Now again we can find out the mole fraction of solute, which is equal to moles of solute divided by total number of moles, that is 1 moles of solute is 1 mole divided by total number of moles, that is 1 plus 55.56. 1 is the mole of solute and 55.56 is the mole of solvent, that is water. And this is equal to 0.02. Now again, relative lowering of vapor pressure is equal to mole fraction of solute. So relative lowering of vapor pressure denoted by P naught minus P divided by P naught is equal to mole fraction of solute, that is 0.02. Solving, we get vapor pressure of solution is equal to 0.98 times the vapor pressure of the solvent. So the vapor pressure of the solution in B is greater than the vapor pressure of the solution in A. Therefore, vapor pressure of the solution in case of B is greater than vapor pressure of the solution in case of A. We can also write it like this: 0.98 times P naught is greater than 0.9 P naught. Therefore, vapor pressure in case of B is greater than vapor pressure in case of A. Question 20. An aqueous solution containing 20% by weight of liquid X, molecular weight equals to 140, has a vapor pressure 160 mm at 60 degrees centigrade. Calculate the vapor pressure of pure liquid X if the vapor pressure of water is 150 mm at 60 degrees centigrade. Now solution containing 20% by weight of liquid X, what does it mean? It means we can write this as 20 divided by 100. Now this is the aqueous solution of a liquid X in water. Now 20% is 20% by weight. So if weight of solute that is X is equal to 20 gram, then weight of solution is equal to 100 gram, and then weight of solvent, that is water, is equal to 100 minus 20, and this is equal to 80 gram. Now we know the weight of solute and weight of solvent. Now pressure of the solution is equal to mole fraction of the solute. XA denotes the mole fraction of solute. Here the solute is a liquid X into vapor pressure of the pure solute plus mole fraction of water. Mole fraction of water is denoted by XB into vapor pressure of pure water denoted by P naught B. P naught A denotes the vapor pressure of pure liquid X. Now mole fraction of the liquid X is equal to moles of the liquid X, which is equal to weight, that is 20, divided by molecular weight of X, which is given as 140, divided by total number of moles. Now total number of moles will be equal to moles of the liquid X plus moles of water. Now moles of water is weight of water, that is 80, divided by molecular weight of water. Now this will be 18. Solving mole fraction of the liquid X is equal to 0.031. Now, when there are two liquids for binary solutions, XA plus XB, that is mole fraction of A plus mole fraction of B, is equal to 1. Therefore, XB is equal to 1 minus XA. So we know the value for XA. So XB will be equal to 1 minus XA. XA is 0.031 and this is approximately equal to 0.97. Now putting the values, let this be equation 1. Now putting the values in equation 1, vapor pressure of the solution is given as 160 millimeter. Mole fraction of the liquid X or XA is equal to 0.031 into vapor pressure of the liquid X denoted by P naught A plus mole fraction of water, that is 0.97 into vapor pressure of pure water, that is 150 millimeter. Solving, the vapor pressure of pure liquid X denoted by P naught A is equal to 468 millimeter. Question 21. At 25 degrees centigrade, benzene and toluene have densities 0.879 and 0.867 gram per centimeter cube respectively. Assuming that benzene-toluene solutions are ideal, establish the equation for the density of the solution. This is the equation that we have to derive, where V is the volume percent of benzene. Volume percent of benzene is given as V. So if the volume of the solution is 100 milliliter, then volume of benzene is V milliliter. तो वॉल्यूम ऑफ बेंजीन हो गया V मिलीलीटर, टोटल वॉल्यूम ऑफ सोल्यूशन है 100 मिलीलीटर, सो वॉल्यूम ऑफ टोलीन हो गया 100 माइनस V, दैट इज टोटल वॉल्यूम ऑफ द सोल्यूशन माइनस वॉल्यूम ऑफ बेंजीन. नाउ density of the solution will be equal to total mass of the solution divided by total volume of the solution. अब total mass of the solution हो जाएगा mass of benzene, let it be m1, plus mass of toluene, let it be m2. So m1 plus m2 will give the total mass of the solution divided by total volume of the solution. Now total volume of the solution is 100 milliliters. So m1 plus m2 divided by 100 will give the density of the solution. Now density of benzene and density of toluene are given. We need to find out the mass of benzene and mass of toluene. So mass is equal to volume into density. So mass of benzene will be equal to density of benzene into volume of benzene. This will give the mass of benzene. So 0.879 into V will give mass of benzene, that is M1, plus density of toluene into volume of toluene will give the mass of toluene. So 0.867 into volume of toluene, that is 100 minus V, will give the mass of toluene, that is the value of M2. So mass of benzene plus mass of toluene divided by volume of the solution, that is 100, will give the density of the solution. So the expression for density becomes 0.879 V plus 0.867 into 100 minus V in brackets divided by 100. Question 22. Ethanol and methanol form a solution that is very nearly ideal. The vapor pressure of ethanol is 44.5 mm and that of methanol is 88.7 mm at 20 degrees centigrade. A. Calculate the mole fraction of methanol and ethanol in a solution obtained by mixing 60 gram of ethanol with 40 gram of methanol. B. Calculate the partial pressure and the total vapor pressure of this solution and the mole fraction of ethanol in the vapor. इथेनॉल का वेपर प्रेशर गिवन है 44.5 मिलीमीटर एंड मिथेनॉल का वेपर प्रेशर गिवन है 88.7 मिलीमीटर. नाउ मिथेनॉल एंड इथेनॉल को मिक्स करके जो सोल्यूशन बना, we need to find the mole fraction of methanol and ethanol in that solution. Now weight of methanol that is dissolved is 40 gram and weight of ethanol that is dissolved is 60 gram. So moles of methanol, methanol is CH3OH, will be equal to weight divided by molecular weight. Weight given है question में 40 gram divided by molecular weight of methanol, that is 32 gram per mole. Similarly, moles of ethanol, weight of ethanol given है 60 gram divided by molecular weight of ethanol, which is 46, will give the moles of ethanol. Now the formula for mole fraction, अगर mole fraction of methanol find out करना है तो formula will be moles of methanol divided by moles of methanol plus moles of ethanol. So mole fraction of methanol is equal to moles of methanol. Methanol का moles कितना हो गया? Weight divided by molecular weight, that is 40 divided by 32 divided by moles of methanol plus moles of ethanol. Ethanol का moles कितना है? 60 divided by 46. 60 is the weight of ethanol and 46 is the molecular weight of ethanol. Solving, mole fraction of methanol is 0.49. Now the solution is of methanol and ethanol. So one of the components has the mole fraction, that is methanol has the mole fraction 0.49. Now for binary solutions, mole fraction of methanol plus mole fraction of ethanol is equal to 1. So mole fraction of ethanol will be equal to 1 minus mole fraction of methanol, and this is equal to 0.51. Now B part, we have to calculate the partial pressure of this solution and the total pressure of this solution and the mole fraction of ethanol in the vapor. Now pressure of the solution is equal to mole fraction of methanol into pressure of pure methanol plus mole fraction of ethanol into pressure of pure ethanol. XA denotes the mole fraction of methanol, P0A denotes the vapor pressure of pure methanol, XB denotes the mole fraction of ethanol, and P0B denotes the vapor pressure of pure ethanol. Putting the values and solving, जो total pressure आया, that is 66.2 millimeter of mercury. Now the individual pressures, 43.5 is the partial pressure of methanol and 22.7 millimeter is the partial pressure of ethanol. So 43.5 millimeter is partial pressure of methanol and 22.7 millimeter is the partial pressure of ethanol and 66.2 millimeter is the total vapor pressure of this solution. Now pressure exerted by ethanol in the vapor state. For that the formula applied will be 1 by P is equal to x dash A divided by P naught A, where x dash A is for the mole fraction of methanol, P naught A is the vapor pressure of pure methanol, plus x dash B divided by P naught B. X dash B is the mole fraction of ethanol in the vapor state and P naught B is the vapor pressure of pure ethanol. Now we know that x dash A plus x dash B is equal to 1. So x dash A is equal to 1 minus x dash B. Putting the values, 1 by 66.2. 66.2 is the total vapor pressure and this is equal to mole fraction of methanol, that is 1 minus x dash B, divided by vapor pressure of pure methanol plus mole fraction of ethanol divided by vapor pressure of ethanol, that is 44.5. Solving, the mole fraction of ethanol in the vapor state is 0.34. Question 23. The vapor pressure of millimeter and that of pure toluene is 75 millimeter at 20 degrees centigrade. What is the composition of the solution of these two components that has a vapor pressure of 50 millimeter at this temperature? What is the composition of vapor in equilibrium with this solution? Formula for the vapor pressure of the solution is equal to XA into P naught A plus XB into P naught B. Now here XB denotes the mole fraction of benzene in the solution and XA denotes the mole fraction of toluene in the solution. P naught A is the vapor pressure of pure toluene and P naught B is the vapor pressure of pure benzene. Now mole fraction of toluene plus mole fraction of benzene is equal to 1. Therefore, mole fraction of benzene can be written as 1 minus mole fraction of toluene. So putting the value of mole fraction of benzene in the formula, we get XA into P naught A plus 1 minus XA into P naught B. Rearranging, we get P naught B plus XA into P naught A minus P naught B. Now putting the values, vapor pressure of the solution given in the question as 50 millimeter and this is equal to vapor pressure of pure benzene, that is 22 millimeter, plus XA, which we have to find out, into in brackets P naught A, which is the vapor pressure of pure toluene given as 75 millimeter, minus vapor pressure of pure benzene, that is 22 millimeter. Solving, we get the mole fraction of toluene in the solution as 0.53. Now we know that mole fraction of toluene plus mole fraction of benzene is equal to 1. Therefore, mole fraction of benzene in the solution will be equal to 1 minus mole fraction of toluene and this is equal to 0.47. So, mole fraction of benzene in the solution is 0.47. Therefore, the ratio of mole fraction of benzene in the solution is to mole fraction of toluene in the solution is equal to 0.47 is to 0.53. Now to find the composition of benzene and toluene present in the vapor state, the formula applied will be 1 by P, where P denotes the vapor pressure of solution, is equal to X dash A. X dash A is the mole fraction of toluene in the vapor state divided by P naught A. P naught A is the vapor pressure of pure toluene plus X dash B. X dash B is the mole fraction of benzene in the vapor state divided by P naught B. P naught B is the vapor pressure of pure benzene and mole fraction of toluene in the vapor state plus mole fraction of benzene in the vapor state is equal to 1. So we can write X dash B as 1 minus X dash A. So 1 by P is equal to X dash A divided by P naught A plus 1 minus X dash A divided by P naught B. Now putting the values, value of P is given as 50 millimeter, vapor pressure of pure toluene is equal to 75 millimeter and vapor pressure of pure benzene is 22 millimeter. Solving, the value of X dash A, that is mole fraction of toluene in the vapor state, is approximately 0.80 and since X dash A plus X dash B is equal to 1, therefore X dash A, that is mole fraction of toluene in the vapor state, is equal to 1 minus 0.80, which is equal to 0.20. Therefore, in the vapor state of the solution, the ratio between the mole fraction of benzene in the vapor state is to mole fraction of toluene in the vapor state is equal to 0.20 is to 0.80. Question 24. A solution containing ethyl alcohol and propyl alcohol has a vapor pressure of 290 millimeter at 30 degrees centigrade. So vapor pressure of the solution of ethyl alcohol and propyl alcohol is 290 millimeter. So let it be P. P is the vapor pressure of solution and this is equal to 290 millimeter. Find the vapor pressure of pure ethyl alcohol. Now let the vapor pressure of pure ethyl alcohol be P naught A. So we need to find the vapor pressure of pure ethyl alcohol if its mole fraction in the solution is 0.65. Mole fraction of ethyl alcohol in the solution is 0.65. So let it be XA. XA denotes the mole fraction of ethyl alcohol in the solution and this is equal to 0.65. The vapor pressure of propyl alcohol is 210 millimeter at the same temperature. So let P naught B denote the vapor pressure of propyl alcohol and this is given as 210 millimeter. Now XB denotes the mole fraction of propyl alcohol in the solution. Now mole fraction of ethyl alcohol plus mole fraction of propyl alcohol is equal to 1. Therefore, mole fraction of propyl alcohol will be equal to 1 minus mole fraction of ethyl alcohol in the solution, which is equal to 0.65. So 1 minus 0.65 is equal to 0.35. 0.35 is the mole fraction of propyl alcohol in the solution. Now applying the formula, vapor pressure of the solution is equal to vapor pressure of pure ethyl alcohol into mole fraction of ethyl alcohol plus vapor pressure of pure propyl alcohol into mole fraction of propyl alcohol. Vapor pressure of the solution 290 millimeter of mercury. Vapor pressure of pure ethyl alcohol, this we have to find out, into mole fraction of pure ethyl alcohol, which is given as 0.65, plus vapor pressure of pure propyl alcohol, that is 210 millimeter of mercury, into mole fraction of propyl alcohol, that is 0.35. Solving, vapor pressure of pure ethyl alcohol is 333.1 millimeter. Question 25. What are partial and total vapor pressures at 25 degrees centigrade above the solution having equal numbers of molecules of benzene and toluene? Now, the number of molecules of benzene and toluene are equal. So, we can write it as number of molecules of benzene is equal to number of molecules of toluene. अब अगर number of molecules same है तो number of moles भी same होगा. So, number of moles of benzene is equal to number of moles of toluene. Now, we can write number of moles of benzene is equal to number of moles of toluene and let this be equal to n. तो नंबर ऑफ मोल्स ऑफ बेंजीन हो गया n, नंबर ऑफ मोल्स ऑफ टोलिन हो गया n. सो टोटल नंबर ऑफ मोल्स n टोटल नंबर ऑफ मोल्स कितना हो जाएगा? नंबर ऑफ मोल्स ऑफ बेंजीन दैट इज n प्लस नंबर ऑफ मोल्स ऑफ टोलिन दैट इज n and this is equal to 2n. Now mole fraction of benzene will be equal to moles of benzene that is n divided by total number of moles that is 2n and this is equal to 0.5. So mole fraction of benzene हो गया 0.5 and we know that mole fraction of benzene plus mole fraction of toluene for binary solutions this is equal to 1. So mole fraction of toluene will be equal to 1 minus mole fraction of benzene that is 1 minus 0.5 and this is equal to 0.5. Now the vapor pressure of benzene and toluene at this temperature are 95.1 and 28.4 millimeter of mercury respectively. So vapor pressure of benzene is 95.1, vapor pressure of toluene is 28.4. What is the composition of the vapor in equilibrium with benzene toluene solution? Now the total vapor pressure of the solution that is P will be equal to mole fraction of benzene into vapor pressure of benzene. Now mole fraction of benzene into vapor pressure of benzene will give the partial pressure of benzene plus mole fraction of toluene into vapor pressure of toluene. Now mole fraction of toluene into vapor pressure of toluene will give the partial pressure of toluene. So putting the values and solving, 47.55 is the partial pressure of benzene and 14.2 is the partial pressure of toluene. So adding partial pressure of benzene and partial pressure of toluene, the total vapor pressure is 61.75 millimeter of mercury. So partial pressure of benzene is 47.55 millimeter of mercury. Partial pressure of toluene is equal to 14.2 millimeter of mercury and total vapor pressure is equal to 61.75 millimeter of mercury. Now to find the composition of the vapor in equilibrium with benzene toluene solution. Now let the mole fraction of benzene in the vapor state be x dash b and mole fraction of toluene in the vapor state be x dash t. So mole fraction of benzene in the vapor state plus mole fraction of toluene in the vapor state is equal to 1. Therefore, mole fraction of toluene in the vapor state is equal to 1 minus mole fraction of benzene in the vapor state. Now to find the composition of the vapor in equilibrium with benzene toluene solution, applying the formula 1 by P where P is the vapor pressure of solution is equal to x dash B divided by P naught B. X dash B is the mole fraction of benzene in the vapor, P naught B is the vapor pressure of benzene plus 1 minus x dash B. 1 minus x dash B is the mole fraction of toluene in the vapor divided by P naught T. P naught T is the vapor pressure of toluene. Now putting the values and solving, x dash B is 0.77 and x dash T will be equal to 1 minus 0.77, that is 0.23. Benzene and toluene form nearly ideal solutions. If at 27 degrees centigrade the vapor pressures of pure toluene and pure benzene are 32.06 millimeter, प्योर टोलिन का वेपर प्रेशर है 32.06 मिलीमीटर ऑफ मर्करी एंड 103.01 मिलीमीटर रेस्पेक्टिवली. प्योर बेंजीन का वेपर प्रेशर है 103.01 millimeter of mercury. Part A. Calculate the vapor pressure of a solution containing 0.60 mole fraction of toluene. Vapor pressure of solution calculate करना है जिसमें कि mole fraction of toluene है 0.6. Now mole fraction of toluene plus mole fraction of benzene is equal to 1. Therefore mole fraction of benzene will be equal to 1 minus mole fraction of toluene and this is equal to 0.4. So the vapor pressure of the solution will be equal to mole fraction of toluene into vapor pressure of pure toluene plus mole fraction of benzene into vapor pressure of pure benzene. Now putting all the values and solving, the vapor pressure of solution is 60.44 millimeter of mercury. B part, calculate the mole fraction of toluene in vapor for this composition of the liquid. Mole fraction of toluene in vapor calculate करना है, तो let the mole fraction of toluene in vapor state be x dash t. Now mole fraction of benzene in the vapor state will be, that is x dash b will be equal to 1 minus x dash t. Why? Because the mole fraction of toluene in vapor state plus mole fraction of benzene in vapor state is equal to 1. 1 divided by vapor pressure of the solution is equal to mole fraction of toluene in the vapor state divided by vapor pressure of pure toluene plus mole fraction of benzene in the vapor state divided by vapor pressure of pure benzene. Putting the values and solving, mole fraction of toluene in the vapor state is equal to 0.318. At 50 degree centigrade, the vapor pressures of pure water and ethyl alcohol are respectively 92.5 millimeter and 219.9 millimeter of mercury. प्योर वाटर का वेपर प्रेशर है 92.5 मिलीमीटर ऑफ मर्करी एंड प्योर इथाइल अल्कोहल का वेपर प्रेशर है 219.9 मिलीमीटर ऑफ मर्करी. इफ 6 ग्राम ऑफ नॉन वोलेटाइल सल्यूट, मतलब वेट ऑफ सल्यूट है 6 ग्राम, ऑफ मॉलिक्यूलर वेट 120, मॉलिक्यूलर वेट ऑफ सल्यूट है 120, is dissolved in 150 gram of each of these solvents, मतलब 6 gram of solute is dissolved in 150 gram of water in one container and 6 gram of solute is also dissolved in 150 gram of ethyl alcohol in another container. What will be the relative vapor pressure lowerings in the two solvent? Now, जब ये सल्यूट डिसॉल्व करेंगे वाटर में और इथाइल अल्कोहल में, then there will be a lowering of vapor pressure of water and ethyl alcohol. So we have to calculate what is the relative lowering of vapor pressure in case of water when this 6 gram of solute is dissolved in water, and the relative lowering of vapor pressure of ethyl alcohol when this 6 gram of solute is dissolved in ethyl alcohol. Now the formula applied will be the relative lowering of vapor pressure is equal to mole fraction of solute. Now moles of water will be equal to weight of water divided by molecular weight of water, that is 150 divided by 18. Moles of ethyl alcohol will be equal to weight of ethyl alcohol divided by molecular weight of ethyl alcohol, that is 150 divided by 46. Moles of solute will be equal to weight of solute divided by molecular weight of solute, that is 6 divided by 120, and this is equal to 0.05 moles. Now in case of water, the relative lowering of vapor pressure is equal to mole fraction of the solute. Now mole fraction of the solute will be equal to moles of solute divided by total number of moles. Now total number of moles will be equal to moles of solute, that is 0.05, plus moles of solvent, that is water, and moles of water is 150 divided by 18, which is equal to 8.33. Solving the relative lowering of vapor pressure in case of water is 0.006. Now relative lowering of vapor pressure in case of ethyl alcohol will be equal to mole fraction of solute which is dissolved in ethyl alcohol. Now mole fraction of the solute will be equal to moles of solute, that is 0.05 moles, divided by moles of solute, that is 0.05 moles, plus moles of solvent, which here is ethyl alcohol. Now moles of solvent, that is moles of ethyl alcohol, is equal to 150 divided by 46, that is weight of ethyl alcohol divided by molecular weight of ethyl alcohol, and this is equal to 3.26. So 0.05 plus 3.26 gives the total number of moles. Solving the relative lowering of vapor pressure of ethyl alcohol will be equal to 0.015. Calculate the molecular weight of a substance, 10 gram of which in 1 liter of solution exerts an osmotic pressure of 81 millimeter of mercury at 27 Kelvin. Now the formula for the osmotic pressure is PV is equal to nRT. N is the number of moles of the solute in the solution. So number of moles is weight divided by molecular weight of the solute into R into T. Now putting the value for the pressure, osmotic pressure. Now osmotic pressure is given as 81 millimeter of mercury. So here it is written 81 divided by 760. So why are we dividing the osmotic pressure by 760? Because the osmotic pressure is given in millimeters of mercury. So we have to convert it into atmospheres. 760 millimeters of mercury is equal to 1 atmosphere. So 81 millimeter of mercury will be equal to 81 divided by 760 atmospheres. So value of osmotic pressure in atmospheres is 81 divided by 760 into volume of solution, that is 1 liter, is equal to weight of solute is given in the question as 10 gram divided by molecular weight into R. The value of R is 0.0821 liters atmosphere per Kelvin per mole. Now since the unit of pressure in the value of R is in atmospheres, we have converted the osmotic pressure from millimeters of mercury to atmospheres. Now into 27. 27 is the temperature in Kelvin. Solving, molecular weight is equal to 207.9 gram per mole. The water vapor pressure at 293 Kelvin is 2338 Pascal and the vapor pressure of an aqueous solution is 2295.8 Pascal. Determine its osmotic pressure at 313 Kelvin if the solution density at this temperature is 1010 kg per meter cube. The molecular weight of the solute is 60. Now applying the formula, density of solution is equal to molarity into, in brackets, 1 divided by molality of the solution plus m dash is the molecular weight of the solute divided by 1000. Density of solution is equal to 1010 kg per meter cube. So converting this density into kg per liter, it will become 1.01 kg per liter. 1 meter cube is equal to 1000 liter. So 1010 kg per meter cube. So 1000 kg divided by, now 1 meter cube is 1000 liters. So instead of writing 1 meter cube, we can write 1000 liter. So it becomes 1.01 kg per liter. Now relative lowering of vapor pressure, that is vapor pressure of pure solvent minus vapor pressure of solution divided by vapor pressure of pure solvent is equal to mole fraction of solute. Mole fraction of solute is moles of solute divided by moles of solute plus moles of solvent, and this is also equal to molality of the solution divided by molality of solution plus 1000 by 18. Now n divided by n plus n is equal to m divided by m plus 1000 by 18. ये कैसे derive हुआ? To derive this, मोल्स ऑफ सल्यूट जो न्यूमरेटर में है उसको डिवाइड कर देंगे वेट ऑफ सॉल्वेंट. अब वेट ऑफ सॉल्वेंट को केजीज में कन्वर्ट करने के लिए वेट ऑफ सॉल्वेंट को डिवाइड करेंगे 1000 से. सो 1000 विल गो टू द न्यूमरेटर, सो इट विल बिकम n into 1000 डिवाइडेड बाय w. सिमिलरली डिनोमिनेटर में भी मोल्स ऑफ सल्यूट को डिवाइड कर देंगे वेट ऑफ सॉल्वेंट से और वेट ऑफ सॉल्वेंट को कन्वर्ट कर देंगे केजीज में. So it will become n into 1000 divided by W plus moles of solvent divided by weight of solvent in kgs. So it becomes n into 1000 divided by W. Now weight of solvent is equal to moles of solvent into molecular weight of solvent. Solvent क्या है? Solvent यहाँ पे water है. So molecular weight of solvent हो जाएगा 18. So putting the value of W, we get n into 1000 divided by W is equal to n into 1000 divided by n into 18. Moles of solvent in numerator and moles of solvent in denominator will get cancelled and we get 1000 divided by 18. So in the numerator, moles of solute divided by weight of solvent in kgs हो गया, ये हो गया equals to molality. Denominator में भी moles of solute divided by weight of solvent in kgs, this is also equal to molality, and moles of solvent divided by weight of solvent in kgs, ये हो गया equal to 1000 divided by 18. So n divided by n plus n is equal to m divided by m plus 1000 by 18. Now vapor pressure of pure solvent minus vapor pressure of solution divided by vapor pressure of pure solvent is equal to 0.018, and this is again equal to molality divided by molality plus 1000 by 18. सॉल्व करेंगे तो मोलालिटी की वैल्यू हो जाएगी 1.018. Now let this be equation 1. Putting the value of molality in equation 1 and density. तो density होगी 1.01. This is equal to molarity. Brackets में 1 divided by molality plus molecular weight of solute given है 60 divided by 1000. So 1.01 is equal to molarity into 1.04. Solving, molarity की वैल्यू हो जाएगी 0.97 moles per liter. Osmotic pressure का फॉर्मूला है PV is equal to nRT. From this, P is equal to N by VRT. Now, N is number of moles and V is volume of solution in liters. So, number of moles divided by volume of solution in liters is equal to molarity of the solution. So, value of N by V is equal to molarity of the solution, and this is equal to 0.97. So, osmotic pressure is equal to 0.97 into value of R is 0.0821 into 313 Kelvin is the temperature, and this is equal to 24.9 atmosphere. So, in atmospheres, the osmotic pressure is 24.9 atmospheres. Converting it into pascals, it will be 2.5 into 10 to the power 6 pascal. This is pascal. वेट ऑफ सल्यूट गिवन है 4.48 ग्राम. मॉलिक्यूलर वेट गिवन है 286 ग्राम पर मोल. वॉल्यूम ऑफ वाटर गिवन है 100 सेंटीमीटर क्यूब. टेम्परेचर इज 298 केल्विन एंड वी हैव टू फाइंड आउट द ऑस्मोटिक प्रेशर ऑफ द सोल्यूशन. वैल्यू ऑफ आर है 82.1 सेंटीमीटर क्यूब एटमॉस्फेयर पर डिग्री पर मोल. Formula for osmotic pressure is osmotic pressure, that is P is equal to N divided by V into R into T. N है number of moles. Now number of moles is equal to weight of solute divided by molecular weight of solute. Weight of solute, that is 4.48 divided by molecular weight of solute, that is 286, will give the number of moles. R की value जो यूज कर रहे हैं इस क्वेश्चन में, that is 82.1. Now in this value of R, the unit of volume is centimeter cube. So volume of solution will be in centimeter cube. N, that is 4.48 divided by 286 divided by volume of solution, that is 100 centimeter cube, into value of R, that is 82.1, into 298, that is the temperature. Solving, osmotic pressure is equal to 3.83 atmosphere. In this question, weight of liquid given है 10.1 gram, which when vaporized occupies volume 4 liters. Temperature है 100 degree centigrade and pressure is given as 70 centimeter of mercury. Now we have to find out the osmotic pressure of 2%. 2%, that is grams per 100 centimeter cube solution of this substance at 0 degree centigrade. Now what is the meaning of 2% in grams per centimeter cube? 2% को हम लिख सकते हैं 2/100. तो 2% का मतलब हो गया न्यूमरेटर में this 2 is the weight of solute. So weight of solute is 2 grams and volume of solution is 100 centimeter cube. Now the value of R used in this question will be 0.0821 liters atmosphere पर केल्विन पर मोल. अब R की वैल्यू में जो वॉल्यूम की यूनिट है वो है लीटर्स और जो प्रेशर की यूनिट है वो है एटमॉस्फेयर्स. सो क्वेश्चन में pressure given है 70 centimeter of mercury. So we have to convert it into atmospheres. Now 76 centimeter of mercury is 1 atmosphere. Therefore 70 centimeter of mercury will be 70 by 76 atmosphere. वॉल्यूम जो 100 सेंटीमीटर क्यूब है उसको कन्वर्ट कर देंगे लीटर्स में. सो दिस 100 सेंटीमीटर क्यूब इज डिवाइडेड बाय 1000 to convert it into liters. Now first of all we need to find out the molecular weight of the volatile liquid. For that we will apply the formula PV is equal to nRT. So N is equal to PV divided by RT. So pressure is 70 divided by 76 atmospheres. Volume is 4 liters. Value of R is 0.0821 and temperature is given as 100 degree centigrade, and 100 degree centigrade when it is converted to Kelvin, that is 273 plus 100, this is equal to 373 Kelvin. So temperature हो गया 373 Kelvin. So number of moles of the volatile liquid is 0.12 moles. अब number of moles पता है, so we can find out the molecular weight of the volatile liquid. Number of moles is equal to weight divided by molecular weight. Number of moles is 0.12 and weight is given as 10.1 gram. So molecular weight will be equal to weight, that is 10.1 gram, divided by number of moles, that is 0.12, and this is equal to 84.2 grams per mole. Now to find the osmotic pressure. Formula for osmotic pressure is N by V R T, where N is the number of moles of the volatile liquid in the solution. अब जिस solution का osmotic pressure find out करना है उसमें weight of the volatile liquid is 2 gram. So number of moles of the volatile liquid will be 2 divided by molecular weight of the volatile liquid, that is 84.2, divided by volume of the solution, which is 100 centimeter cube, and in liters it is 100 divided by 1000 liters, into R, value of R is 0.0821, into T, temperature at which we have to find out the osmotic pressure is 0 degree centigrade, which is equal to 273 Kelvin. Solving, the osmotic pressure is 5.32 atmosphere. Average osmotic pressure of human blood given है 7.7 atmosphere at 40 degree centigrade. Find out करना है total concentration of various solutes in the blood. अब concentration कैसे find out करेंगे? Concentration होगा moles per liter. Means we have to find out molarity of the solution. Osmotic pressure is equal to N divided by V into R into T. Here N is the number of moles and V is the volume of solution in liters. So N divided by V is concentration in moles per liter, which is also known as molarity. N by V is equal to P divided by RT. P की value given है 7.7 atmosphere. R will be 0.0821. Temperature given है 40 degree centigrade. Temperature को Kelvin में convert करेंगे, then it will be 273 plus 40, which is equal to 313 Kelvin. So temperature is 313 Kelvin. Solving, the concentration of solutes in the blood is 0.29 moles per liter. Now B part, assuming this concentration to be same as the molality, means assuming that the molality of the solution is also 0.29 moles per kg of solvent, we have to find the freezing point of blood. Value of Kf for water is given as 1.86. So delta Tf, that is depression in freezing point, is equal to Kf into m. This m is molality of the solution. Kf की value है 1.86, molality की value है 0.29. So Kf into m is equal to 1.86 into 0.29, that is 0.5394 degrees centigrade. Now what is delta Tf? Delta Tf is freezing point of pure solvent minus freezing point of solution, and this is equal to 0.5394. Therefore, freezing point of solution will be equal to, अब solvent water है, therefore freezing point of pure water is 0 degree centigrade and freezing point of solution will be 0 minus 0.5394, which is equal to minus 0.5394 degree centigrade. Solution containing 10.2 gram of glycerine per liter means weight of glycerine है 10.2 gram और volume of solution है 1 liter, is found to be isotonic with a 2% solution of glucose. Isotonic with 2% solution of glucose means 2% solution of glucose and the solution of glycerine, they are having the same molarity, दोनों की molarity same है. Calculate the molecular weight of glycerine. Molecular weight of glucose given है 180 gram per mole. So molarity of glycerine solution और molarity of glucose solution same है. अब molarity of glycerine क्या होगा? Moles of glycerine divided by volume of solution in liters. और moles of glycerine होगा weight of glycerine divided by molecular weight of glycerine. अब weight of glycerine given है 10.2 gram और molecular weight of glycerine we have to find out. तो molarity of glycerine solution हो गया, let it be M1, ये हो जाएगा 10.2 divided by molecular weight of glycerine into volume of solution which is given in the question as 1 liter. ये हो गया molarity of glycerine. अब molarity of glucose solution, let it be M2, will be equal to, now glucose solution जो है that is 2% solution of glucose. 2% solution of glucose means weight of glucose is 2 gram and divided by volume of solution is 100 milliliters. Now this has to be converted into liters. So 100 divided by 1000 will give the volume of solution in liters. M2 हो जाएगा moles of glucose. अब moles of glucose कितना होगा? Moles of glucose होगा weight of glucose, that is 2 divided by molecular weight of glucose. Question में given है 180 divided by volume of solution in liters, that is 100 divided by 1000. ये हो गया molarity of glucose solution. Now according to the question, the solutions are isotonic, means M1 is equal to M2. M1 equals to M2 will be this equation. Now solving this equation, molecular weight of glycerine is equal to 91.8 gram per mole. This is M2 and this is M1. So M1 is equal to M2 or M2 is equals to M1. Osmotic pressure of aqueous solution of sucrose, जिसमें कि 45 ग्राम of sucrose, molecular weight 343 grams per mole in 1 liter of solution is given as 2.97 atmosphere. Temperature given as 0 degree centigrade, which means in Kelvin the temperature is 0 plus 273 and this is equal to 273 Kelvin. Find the value of gas constant, मतलब R की value find out करनी है and compare the result with the accepted value. Osmotic pressure का formula है N divided by V into R into T. Osmotic pressure की value given है 2.97. N is the number of moles, that is weight divided by molecular weight. Here weight of sucrose, that is 45 divided by molecular weight of sucrose, that is 343 divided by volume of solution which is given as 1 liter into R into temperature, that is 273 Kelvin. On solving, the value of R is 0.0829 liters atmosphere per Kelvin per mole. And the value of R which is used in calculations is 0.0821 liters atmosphere per Kelvin per mole. What weight of glycerol would have to be added to 1000 gram of water in order to lower its freezing point by 10 degrees centigrade? Kf is equal to 1.86. Depression in freezing point, that is delta Tf, is equal to Kf into m. Here m is molality. Now in the question they have asked, what will be the weight of glycerol which should be added to 1000 gram of water so that its freezing point is lowered by 10 degrees centigrade. Now molality of the solution will be equal to delta Tf divided by Kf, which is equal to 10 divided by 1.86. Now what is molality? Molality is number of moles divided by weight of solvent in kgs. So if W is the weight of solvent, to convert it into kgs, it will become W divided by 1000 kg. And number of moles will be equal to weight of solute divided by molecular weight of the solute. Molality is equal to 10 divided by 1.86, and molality is equal to number of moles divided by weight of solvent in kgs. Number of moles is weight of solute, let it be W, divided by molecular weight of solute. Molecular weight of glycerol is 92. So W by 92 gives the number of moles of the solute divided by weight of solvent in kg. Now weight of solvent in this question is 1000 gram. So converting it into kgs, 1000 gram will be equal to 1000 divided by 1000, which is equal to 1 kg. So W by 92 divided by weight of solvent, which is 1 kg, is equal to 10 divided by 1.86. Solving, weight of glycerol will be equal to 495 grams. An aqueous solution contains 10% by weight of urea, molecular weight is 60, and 5% by weight of glucose, molecular weight is 180. What will be its freezing point? K for water is 1.86. Now the solvent here is water, and in this water 10% by weight of urea is dissolved and 5% by weight of glucose is dissolved. So in the same solvent two solutes are dissolved, one is urea and one is glucose. अब 10% by weight मतलब क्या होता है? 10% by weight मतलब हो गया 10 by 100. तो weight of solute हो गया 10 ग्राम, weight of solution हो गया 100 ग्राम, and 5% by weight मतलब हो गया 5 by 100, weight of solute हो गया 5 ग्राम and weight of solution हो गया 100 gram. Now urea and glucose are dissolved in the same solvent. So the weight of solution is equal to 100 gram. Weight of solute will be equal to 10 gram of urea plus 5 gram of glucose, which is equal to 15 gram, and weight of solvent will be equal to weight of solution, that is 100 gram, minus weight of solute, that is 15 gram, and this is equal to 85 gram. तो weight of solvent हो गया 85 gram. Now molality of solution with respect to urea and molality of solution with respect to glucose find out करेंगे. Let the molarity of solution with respect to urea be m1 और ये हो जाएगा moles of urea, that is weight of urea divided by molecular weight of urea, that is 10 divided by 60 divided by weight of solvent in kgs. अब weight of solvent है 85 ग्राम, इसको कन्वर्ट करेंगे kgs में तो ये हो जाएगा 85 divided by 1000 kg. So molality of solution हो गया 1.96. Similarly, molality of solution with respect to glucose will be equal to moles of glucose. अब moles of glucose कितना होगा? Moles of glucose होगा weight of glucose, that is 5 gram, divided by molecular weight of glucose, that is 180 gram per mole, divided by weight of solvent in kgs. अब weight of solvent in kgs क्या होगा? Weight of solvent हो गया 85 divided by 1000. This will give the weight of solvent in kgs. So molality with respect to glucose, that is M2, will be equal to 0.327. Now delta TF of this solution containing urea and glucose, that is depression in freezing point of this solution containing urea and glucose, will be equal to Kf into, in brackets, molality with respect to urea and molality with respect to glucose, and this is equal to 1.86 into, in brackets, 1.96 plus 0.327. Solving, the depression in freezing point will be equal to 4.254 degrees centigrade. अब depression in freezing point क्या होता है? Depression in freezing point होता है freezing point of pure solvent minus freezing point of solution, and this is equal to 4.254 degrees centigrade. अब solvent यहाँ पे है water, so freezing point of pure solvent will be equal to 0 degrees centigrade. Now putting the value of freezing point of pure solvent, the freezing point of solution will be equal to 0. 0 is the freezing point of pure solvent minus 4.254, and this is equal to minus 4.254 degrees centigrade. So freezing point of this solution is equal to minus 4.254 degrees centigrade. If glycerin and methyl alcohol are sold at the same price per kg, which would be cheaper for preparing an antifreeze solution for the radiator of an automobile? Delta TF is equal to Kf into M. Here M is the molality. Out of glycerin and methyl alcohol, जिसका delta TF का value ज़्यादा होगा, that will be better for preparing an antifreeze solution. Now value of delta TF depends upon the molality of the solution. और molality की value क्या होती है? Molality is equal to number of moles divided by weight of solvent in kg. Weight of solvent in kg. Now in case the solvent is same for both glycerin and methyl alcohol, then for the same weight of glycerin and methyl alcohol, suppose हम 100 ग्राम of glycerin लेते हैं और 100 ग्राम of methyl alcohol लेते हैं, तो weight तो same है, number of moles of methyl alcohol will be greater than the number of moles of glycerin. Why? Because molecular weight of glycerin is very high in comparison to the molecular weight of methyl alcohol. Number of moles of glycerin will be equal to 100 divided by molecular weight of glycerin, and number of moles of methyl alcohol होगा 100 divided by molecular weight of methyl alcohol. Now since the molecular weight of glycerin is very high in comparison to molecular weight of methyl alcohol, number of moles of glycerin will be less than number of moles of methyl alcohol. Now number of moles of methyl alcohol is greater, so molality of methyl alcohol will also be greater than glycerin, and since the molality of methyl alcohol is greater than glycerin, the depression in freezing point produced due to methyl alcohol will be greater than the depression in freezing point produced by glycerin. Therefore, methyl alcohol will be cheaper for preparing an antifreeze solution. Moreover, since the number of moles of methyl alcohol is greater than number of moles of glycerin, number of particles in solution of methyl alcohol will be greater than the number of particles of glycerine, as a result of which the depression in freezing point produced by methyl alcohol will be greater than that produced by glycerine. How much ice will separate if a solution containing 25 gram of ethylene glycol in 100 gram of water is cooled to minus 10 degrees centigrade? Kf for water is given as 1.86. When solution of ethylene glycol is cooled to minus 10 degrees centigrade, then some amount of ice separates out. We can consider this temperature, that is minus 10 degrees centigrade, as the freezing point of the solution of ethylene glycol in water. Now, freezing point of the solution is minus 10 degrees centigrade, and depression in freezing point, that is delta Tf, is equal to freezing point of pure solvent minus freezing point of solution. Freezing point of pure solvent क्या है? Freezing point of pure solvent है 0 degree centigrade because the solvent is water, minus अब freezing point of solution given है minus 10 degree centigrade, तो ये हो जाएगा minus 10 degree centigrade. Therefore, freezing point depression will be equal to 10 degree centigrade. This is the value of delta Tf. Now, let us assume that the weight of ice that separates out, let it be x grams. Therefore, initially जो weight of water था वो 100 gram था. Now, after x gram of ice separates out, the weight of water will be 100 minus x gram. So, at minus 10 degree centigrade, 25 gram of ethylene is present in 100 minus x gram of water. Now, molality of the solution will be equal to moles of solute. Solute क्या है? Solute है ethylene glycol, and moles of ethylene glycol हो जाएगा weight of ethylene glycol, that is 25 gram, divided by molecular weight of ethylene glycol, that is 62 gram per mole, divided by weight of solvent in kgs. Now, weight of solvent here is 100 minus x gram, और इसको kg में convert करेंगे. For that, we will divide it by 1000. So, molality is equal to 25 into 1000 divided by 62 into in brackets 100 minus x. Now, depression in freezing point is equal to Kf into m. Therefore, m will be equal to delta Tf divided by Kf. Now, from equations 1 and 2, equation 1 and 2 both are showing the molality of the solution. Therefore, equation 1 is equal to equation 2. Putting the values, we get 25 into 1000 divided by 62 into in brackets 100 minus x is equal to 10 divided by 1.86. Solving 100 minus x is equal to 75 gram. Therefore, x is equal to 100 minus 75, that is 25 grams. So, amount of ice that separates out from a solution of 25 gram of ethylene glycol in 100 gram of water when it is cooled to minus 10 degree centigrade is 25 gram. What approximate proportions by volume of water? Density of water given है 1 gram per centimeter cube and ethylene glycol C2H6O2 density given है 1.12 gram per centimeter cube must be mixed to ensure protection of an automobile cooling system to minus 10 degrees centigrade. So in this question they have asked that in what proportion by volume. this water and ethylene glycol must be mixed so that the depression in freezing point is 10 degrees centigrade. Ratio of volume of water and volume of ethylene glycol क्या होगा mixture में so that the depression in freezing point is 10 degrees centigrade. Now let the volume of water divided by volume of ethylene glycol let it be equal to x. इसको inverse कर देंगे तो volume of ethylene glycol divided by volume of water will be equal to 1 by x. Now we know that mass by volume is equal to density. So volume is equal to mass by density. Now instead of writing volume of ethylene glycol and volume of water, we can also write weight of ethylene glycol divided by density of ethylene glycol. Density of ethylene glycol is given as 1.12 and weight of water divided by density of water, that is 1 gram per centimeter cube, and this is equal to 1 by x. सिंप्लीफाई करके लिखेंगे तो ये आ जाएगा weight of ethylene glycol divided by weight of water into 1.12. Now 1.12 को इक्वेशन की राइट हैंड साइड में ले जाएंगे, so it becomes 1 by x into 1.12. Now weight of water को ग्राम से कन्वर्ट करेंगे kgs में, so weight of water will be divided by 1000. Now this 1000 goes to the numerator and we get the weight of water in kgs. अब लेफ्ट हैंड साइड ऑफ इक्वेशन को मल्टीप्लाई किया है 1000 से, therefore राइट हैंड साइड ऑफ द इक्वेशन को भी मल्टीप्लाई करेंगे 1000 से. So on the right hand side of the equation we get 1 by x into 1000 into 1.12. Now weight of ethylene glycol को डिवाइड कर देंगे उसके molecular weight से, that is 62. The right hand side of the equation also we will divide by 62. So it becomes 1 by x into 1000 into 1.12 divided by 62. A weight of ethylene glycol divided by 62 is equal to moles of ethylene glycol. Therefore, on the left hand side of the equation we have moles of ethylene glycol divided by weight of water in kgs, which is equal to molality of ethylene glycol. So molality of ethylene glycol is equal to 1000 into 1.12 divided by x into 62. Now depression in freezing point is equal to kf into molality. Depression in freezing point की value given है, that is 10 degree centigrade, and this is equal to kf. kf for water is 1.86 into molality की value हो गई 1000 into 1.12 divided by x into 62. Solving, x की value हो गई 3.36. Therefore, volume of water is to volume of ethylene glycol is equal to 3.36 is to 1. अब 3.36 is to 1 को अगर हम 3 से मल्टीप्लाई कर दें, then we get the ratio as 10 is to 3. जीरो 0.2 ग्राम ऑफ पॉलीआइसोब्यूटाइलिन को डिजोल्व किया 100 सेंटीमीटर क्यूब ऑफ बेंजीन में, एंड देर इज अ राइज ऑफ 2.4 मिलीमीटर एट ऑस्मोटिक इक्विलिब्रियम. टेम्परेचर है 25 डिग्री सेंटीग्रेड. मॉलिक्यूलर वेट कैलकुलेट करना है पॉलीआइसोब्यूटाइलिन का if the density of the solution is 0.88 gram per centimeter cube. Now the pressure, the osmotic pressure is not given in terms of millimeter of mercury. So it has to be converted into millimeters of mercury or centimeters of mercury. Now pressure can also be expressed in terms of height of mercury column into density of mercury into acceleration due to gravity. Now let the height of mercury column be h dash, density of mercury be d dash, and acceleration due to gravity is g, and this is equal to height in terms of this solution into density of the given solution into acceleration due to gravity. Now acceleration due to gravity को cancel कर देंगे because it is same on both the sides, and we get H dash into density of mercury, that is 13.6 gram per centimeter cube. This is equal to height in terms of this solution 2.4 millimeter or 0.24 centimeter into density of this solution, that is 0.88. Solving, height of the mercury column is 0.0155 centimeter of mercury, and this can be converted into atmospheres by dividing it by 76. So the osmotic pressure in atmospheres हो गया 0.0155 divided by 76 atmosphere. Now formula applied for osmotic pressure calculation is P is equal to N by V RT. Now P is the osmotic pressure of the solution, that is 0.0155 divided by 76 atmosphere. N is the number of moles of the solute, which is equal to weight divided by molecular weight of the solute. Weight of solute given है question में, that is 0.2 gram divided by molecular weight of the solute. This molecular weight of the solute we have to find out. Value of R will be 0.0821 liters atmosphere per Kelvin per mole, और temperature हो गया 25 डिग्री सेंटीग्रेड और 298 केल्विन, एंड वॉल्यूम ऑफ बेंजीन जिसमें डिसॉल्व किया है पॉलीआइसोब्यूटाइलिन को, बेंजीन इज द सॉल्वेंट, so volume of benzene is given in centimeter cube. So convert this volume of benzene into liters, that is volume of benzene is equal to 100 divided by 1000 liters. Now putting the values in the equation for the calculation of osmotic pressure, that is P is equal to N by V RT. Let this be equation number 1, and solving, the molecular weight of the solute is equal to 2.39 into 10 to the power 5 gram per mole. Unknown substance whose weight is 0.1 gram. It is dissolved in 5 gram of camphor. Means here the solvent is camphor. And melting point of camphor was depressed by 5.3 degrees centigrade. Means the value of delta TF will be 5.3 degrees centigrade. Value of Kf is given as 39.7. We have to find the weight of 1 mole of the solute. Now weight of 1 mole of solute means we have to find the molecular weight of the solute. Now applying the formula, delta TF is equal to Kf into M. Value of Kf is given in the question and it is equal to 39.7. Now we have to find out M. What is M? M is the molality of the solution. And the formula for molality of the solution is moles of solute divided by weight of solvent in kg. This is the formula, and in case the weight of solvent is given in grams, then the formula becomes number of moles divided by weight of solvent in grams into 1000. When we are dividing the weight of solvent in grams by 1000 to convert it into kgs, this 1000 goes into the numerator and the formula becomes number of moles of solute into 1000 divided by weight of solvent in grams. Now here weight of camphor is given as 5 gram. So weight of camphor in kgs will be equal to 5 divided by 1000 kg. Now number of moles of the solute will be equal to weight of solute, that is 0.1 gram divided by molecular weight of the solute. Now molecular weight of the solute we have to find out. Let this be equation 1. So putting the values in equation 1, we get 5.3 is equal to 39.7 into molality of solution. This is the molality of solution. Now 0.1 is the weight of the solute divided by molecular weight will give the number of moles of the solute into 1000 divided by weight of solvent in grams. The weight of solvent in grams is given as 5 grams. Solving, the molecular weight of the solute is 150 grams per mole. 1.23 gram of a substance is dissolved in 10 gram of water. Means the solvent is water. Raised the boiling point of water to 100.39 degrees centigrade. Calculate the molecular weight of the substance. The value of Kb is given as 0.52. What is elevation of boiling point? Now on adding solute, the boiling point was raised to 100.39 डिग्री सेंटीग्रेड. मीन्स प्योर वाटर का बॉइलिंग पॉइंट है 100 डिग्री सेंटीग्रेड. ऑन एडिंग द सल्यूट, द बॉइलिंग पॉइंट ऑफ द सॉल्यूशन is 100.39 degree centigrade. Means there is elevation of boiling point, and the elevation of boiling point will be equal to boiling point of solution minus boiling point of pure solvent, and this is equal to 100.39 minus 100, and this is equal to 0.39 degree centigrade. So this is the elevation in boiling point. Now boiling point elevation is equal to Kb into m. Value of delta Tb is 0.39 degree centigrade. Value of Kb is given in the question as 0.52, and m is the molality. Now what will be the molality of this solution? Molality of solution क्या होता है? Molality of solution होता है number of moles divided by weight of solvent in kg. अब number of moles of solute कितना होगा? Number of moles of solute होगा weight of solute, which is given in the question as 1.23 gram, divided by molecular weight of solute divided by weight of solvent. कितना given है question में? Weight of solvent is given as 10 gram. So weight of solvent को convert करना होगा kgs में. So 10 divided by 1000 is the weight of solvent in kg, and this becomes equal to 1.23 divided by molecular weight into 1000 by 10. This is the molality of the solution. So delta Tb, that is 0.39, is equal to 0.52. This is the value of Kb into molality of the solution. Solving, the molecular weight of the solute is 164 gram per mole. Two elements A and B form compounds having formula AB2 and AB4. When dissolved in 20 gram of benzene, means the solvent is benzene, 1 gram of AB2 lowers the freezing point by 2.3 degree centigrade, whereas 1 gram of AB4 lowers the freezing point by 1.3 degree centigrade. Calculate the atomic weights of A and B. Kf for benzene is 5.1. Now depression in freezing point, that is delta Tf, is equal to Kf into m, और m क्या है? m है molality. So delta Tf is equal to Kf into molality. क्या होगी? molality होगी moles of solute divided by weight of solvent in kg, और moles of solute हो जाएगा weight of solute, that is 1 gram, divided by molecular weight of solute, which is not given, we have to find out, and weight of solvent in kg हो जाएगा, weight of solvent is given in grams, so 20 divided by 1000 kgs. Now putting the value of delta Tf as 2.3 degree centigrade, this is for AB2, value of Kf equals to 5.1, weight of solute, that is 1 gram, divided by molecular weight of solute, which we have to find out. Weight of solvent in kgs will be 20 divided by 1000 kg. Putting these values and rearranging, the molecular weight of AB2 is equal to 5.1 into 1 into 1000 divided by 2.3 into 20. Solving, molecular weight of AB2 आ जाएगा 110.87 gram per mole. Similarly, delta Tf for AB4 will be equal to Kf into molality of the solution. Molality of the solution हो जाएगा number of moles of solute divided by weight of solvent in kgs. Now here the number of moles of solute is again weight of solute, that is 1 gram divided by molecular weight of solute, which we have to find out. Weight of solvent in kgs will be, now AB4 is also dissolved in 20 gram of benzene. So weight of benzene in kgs will be 20 divided by 1000 kg. Delta TF की value होगी for AB4, it is 1.3 degree centigrade, and value of Kf for benzene is 5.1. Putting the values and rearranging, molecular weight of AB4 हो जाएगा 5.1 into 1 into 1000 divided by 1.3 into 20, and molecular weight of AB4 is 196.15 gram per mole. Now in both AB2 and AB4, all the values are same, only the depression in freezing point due to AB2 is 2.3 degree centigrade and due to AB4 is 1.3 degree centigrade. Now let us assume that atomic weight of A is equal to X and atomic weight of B is equal to Y. Now one molecule of AB2 has one atom of A and two atoms of B. Therefore its molecular weight will be atomic weight of A, that is X, plus number of atoms of B into atomic weight of B, that is 2 into Y, which is equal to 2Y. So molecular weight of AB2 हो गया X plus 2Y, and from calculations we know that molecular weight of AB2 is 110.87. Therefore X plus 2Y is equal to 110.87. Now one molecule of AB4 contains one atom of A and 4 atoms of B. Therefore molecular weight of AB4 will be number of atoms of A into atomic weight of A, that is 1 into X, which is equal to X, plus number of atoms of B into atomic weight of B, that is 4 into Y, which will be equal to 4Y. So molecular weight of AB4 हो गया X plus 4Y, and this is equal to, from calculations we know that molecular weight of AB4 is 196.15. So this is equal to 196.15. Now subtracting the atomic weight of AB2 from atomic weight of AB4, we get the value of 2Y equals to 85.28. From this, the value of Y is equal to 42.64 grams per mole, and putting the value of Y in the equation X plus 2Y is equal to 110.87, and solving, the value of X is equal to 25.59 grams per mole. अब X क्या है? X है atomic weight of A. So A का atomic weight हो गया 25.59 grams per mole, and Y is the atomic weight of B. So atomic weight of B हो गया 42.64 grams per mole. "45 gram of glucose was dissolved in 500 gram of water. So weight of solute, that is glucose, is 45 gram and weight of solvent, that is water, is 500 gram. The solution has a freezing point of minus 0.93 degree centigrade. A. What is the molecular weight of glucose? सॉल्वेंट यहाँ पे वाटर है और प्योर सॉल्वेंट का फ्रीजिंग पॉइंट होता है 0 डिग्री सेंटीग्रेड. फ्रीजिंग पॉइंट ऑफ सोल्यूशन गिवन है, सोल्यूशन ऑफ ग्लूकोज इन वाटर, उसका फ्रीजिंग पॉइंट गिवन है, फ्रीजिंग पॉइंट ऑफ सोल्यूशन इज इक्वल टू माइनस 0.93 डिग्री सेंटीग्रेड. सो डिप्रेशन इन फ्रीजिंग पॉइंट क्या हो जाएगा? डिप्रेशन इन फ्रीजिंग पॉइंट हो जाएगा freezing point of pure solvent, that is 0, minus freezing point of solution, that is minus 0.93, and this is equal to 0.93 degree centigrade. अब molecular weight of glucose find out करना है. The formula applied will be delta TF is equal to KF into M. m is the molality of the solution and this is equal to kf into molality का फॉर्मूला हो जाएगा नंबर ऑफ मोल्स ऑफ सोल्यूट डिवाइडेड बाय वेट ऑफ सॉल्वेंट इन kgs. अब नंबर ऑफ मोल्स ऑफ सोल्यूट हो जाएगा वेट ऑफ सोल्यूट दैट इज 45 ग्राम डिवाइडेड बाय मॉलिक्यूलर वेट ऑफ सोल्यूट. Molecular weight of solute we don't know, we have to find out. And weight of solvent in kgs will be weight of solvent in grams, that is 500 grams divided by 1000. This will give the weight of solvent in kgs. Delta TF की वैल्यू हो जाएगी 0.93 degree centigrade and value of KF will be 1.86. Putting the values and solving, the molecular weight of the solute, that is glucose, is 180 grams per mole. B part. If the simplest formula is CH2O, what is the molecular formula? So CH2O is the empirical formula. CH2O is the empirical formula. Empirical formula से empirical formula weight निकाल लेंगे, which is equal to, in the empirical formula there is one atom of carbon, so 1 into atomic weight of carbon, that is 12, plus 2 atoms of hydrogen, so 2 into atomic weight of hydrogen, that is 1, plus 1 atom of oxygen, that is 1 into atomic weight of oxygen, that is 16. Solving, this is equal to 30. Now empirical formula से molecular formula अगर find out करना है, then empirical formula multiplied by n. Now what is n? N is equal to molecular formula weight divided by empirical formula weight. So molecular formula weight तो हो गया 180 because it is the molecular weight, divided by empirical formula weight हो गया 30. So 180 divided by 30 will give the value of n, which is equal to 6. Putting the value of n, this becomes a CH2 in brackets and in place of n it is 6. So the molecular formula becomes C6H12O6. Calculate Kb of water when 1 mole of the solute is dissolved in 1000 gram of water. The latent heat of vaporization of water is 539.9 calories per gram. Formula is Kb is equal to R into T square divided by 1000 into latent heat of vaporization. अब latent heat of vaporization में जो heat की unit use हुई है वो है calories. So R की value हम calories में लेंगे. So it will be 2 into T is the boiling point of pure water. तो boiling point of pure water है 100 degree centigrade, which in kelvins will be 273 plus 100 and this is equal to 373 Kelvin. So T square will be 373 square divided by 1000 into latent heat of vaporization is given as 539.9. Solving, value of Kb will be equal to 0.514. Molar elevation constant of chloroform is 3.88, means this is the value of Kb. 0.3 gram of camphor added to 25.2 gram of chloroform. Solute है camphor, weight of solute हो गया 0.3 gram. Solvent है chloroform, weight of solvent है 25.2 gram. Raised the boiling point of solvent by 0.299 degree centigrade, means delta Tb की value हो गई 0.299 degree centigrade. Calculate the molecular weight of camphor. Now, number of moles of solute, that is camphor, will be 0.3 grams, that is weight, divided by molecular weight of camphor. Now we have to find out the molecular weight of camphor. Weight of solvent in kgs हो गया 25.2 divided by 1000 kg and value of delta TB is given as 0.299 degree centigrade and value of KB is given as 3.88. Now applying the formula, delta TB is equal to KB into M. M is the molality of the solution and this is equal to KB into molality of solution will be equal to moles of solute, that is 0.3 divided by molecular weight of the solute divided by weight of solvent in kgs. Weight of solvent in kgs is given as 25.2 divided by 1000 kg. Value of delta TB is given, KB is given. Putting the values we get this equation and solving we get the molecular weight of the solute as 154 gram per mole. मोलर डिप्रेशन कांस्टेंट ऑफ वाटर फाइंड आउट करना है, which means value of Kf find out करना है. And latent heat of fusion of ice given है 80 calories per gram और temperature given है 0 degree centigrade. So Kf is equal to RT square divided by 1000 into LF. Now here the value of R will be taken in which the unit of heat will be calories. So value of R will be equal to 2 and temperature is in kelvins. So 0 degree centigrade means 273 Kelvin. LF means latent heat of fusion which is given in the question as 80 calories per gram. So putting the values and solving, the value of Kf is equal to 1.86. Value of R is 2 calories per Kelvin per mole. Value of Kb for CCl4 is given as 5.02. CCl4 का boiling point given है 76.8 degree centigrade. Calculate the boiling point of 1 molar solution of naphthalene in CCl4. Means यहाँ solute है naphthalene and solvent है CCl4. Solution की molality है 1. So Kb is equal to 5.02. Boiling point of pure solvent is 76.8 degree centigrade. Boiling point of solution we have to find out and molality of solution is given in the question as 1 m. Now the formula is delta TB is equal to Kb into m. So Kb हो गया 5.02 into m हो गया 1. डेल्टा TB की वैल्यू हो गई 5.02 डिग्री सेंटीग्रेड. अब डेल्टा TB क्या होता है? डेल्टा TB होता है बॉइलिंग पॉइंट ऑफ सॉल्यूशन minus boiling point of pure solvent. Here the solvent is carbon tetrachloride. So boiling point of solution of naphthalene in carbon tetrachloride minus boiling point of pure carbon tetrachloride is equal to 5.02. Boiling point of pure carbon tetrachloride is given in the question as 76.8 degree centigrade. Therefore, boiling point of the solution will be equal to 5.02 plus 76.8 and this is equal to 81.82 degree centigrade. वैल्यू ऑफ Kb फॉर क्लोरोफॉर्म कैलकुलेट करना है. गिवन डेटा है boiling point of pure chloroform that is 61.3 degree centigrade and the solution containing 5.02 gram of naphthalene in 18 gram of CHCl3 boils at 69.5 degree centigrade. Means Solute is naphthalene and it is dissolved in the solvent chloroform. Weight of solvent is 18 gram and the solution boils at 69.5 degrees centigrade. So given data is boiling point of pure solvent, that is 61.3 degrees centigrade. Kb we have to find out. Boiling point of solution is 69.5 degrees centigrade. Weight of solute given है, weight of solvent given है, so molality of solution can be calculated. Molality of solution will be equal to moles of solute, which is equal to weight of solute given as 5.02 gram, divided by molecular weight of solute. Molecular weight of naphthalene is 128 gram per mole, divided by weight of solvent in kgs. So weight of solvent is given in grams, that is 18 gram. So convert करेंगे kgs में, it will be 18 divided by 1000 kg. Molality का formula है moles of solute divided by weight of solvent in kgs and moles of solute हो जाएगा weight of solute divided by molecular weight of solute divided by weight of solvent in kgs हो जाएगा weight of solvent in gram divided by 1000. Now elevation in boiling point will be equal to boiling point of solution, that is 69.5 degrees centigrade, minus boiling point of the pure solvent, that is 61.3 degree centigrade, and this is equal to 8.2 degrees centigrade. Now delta TB is equal to KB into M. Delta TB की value है 8.2, KB we have to find out. This is the value of M, that is molality. Solving, value of KB is equal to 3.8 degrees centigrade and this M stands for molality. So M raised to the power -1. Molality की unit होती है moles of solute per kg of solvent. So 1 by M हो जाएगा M raised to the power -1 and this is also equal to kg per mole. Just inverse हो जाएगा. So value of Kb can also be written as 3.8 degree centigrade kg per mole. Weight of solute given है solution में 1.23 gram of calcium nitrate. So solute is calcium nitrate. Weight of solvent is 10 gram and the solvent is water. Solution का boiling point given है 100.975 degree centigrade and we have to calculate the degree of ionization of the nitrate. Kb की value है 0.52. Pure water का boiling point होता है 100 degree centigrade. Boiling point of solution given है 100.975 degree centigrade. Therefore, elevation of boiling point will be equal to boiling point of solution, that is 100.975 degree centigrade minus 100 degree centigrade, and this is equal to 0.975 डिग्री सेंटीग्रेड. अब कैल्शियम नाइट्रेट डिसोसिएट करेगा सॉल्यूशन में टू फॉर्म कैल्शियम आयंस एंड नाइट्रेट आयंस. इनिशियली 1 mole of calcium nitrate is there, then moles of calcium ions is 0 and moles of nitrate ion is 0. After dissociation, let x moles of calcium nitrate dissociate to form calcium ions and nitrate ions. After dissociation, moles of calcium ions will be x moles, moles of nitrate ions will be 2x moles, and moles of calcium nitrate remaining is 1 minus x moles. So total number of moles after dissociation हो गया 1 minus x plus 2x. that is moles of calcium nitrate plus moles of calcium ions plus moles of nitrate ions, and this is equal to 1 plus 2x moles, and moles of solute particles before dissociation था 1 mole. Now value of I हो जाएगा moles of solute particles after dissociation, that is 1 plus 2x, divided by moles of solute particles before dissociation, that is 1. ये हो गया value of I considering the number of particles of solute before and after dissociation. Now delta TB is equal to I into Kb into M. Delta TB is 0.975 and this is equal to I into Kb is given as 0.52 into molality of the solution will be moles of solute, that is moles of calcium nitrate. अब moles of calcium nitrate हो जाएगा weight of calcium nitrate, that is 1.23, divided by molecular weight of calcium nitrate, that is 164, divided by weight of solvent in kgs, that is 10 divided by 1000. Rearranging, the value of I will be equal to, solving the value of I will be equal to 2.5. तो यहाँ पे I की वैल्यू हो जाएगी 1 plus 2x divided by 1 is equal to 2.5 and 2x will be equal to 2.5 minus 1 equals to 1.5. Therefore x will be equal to 0.75. Therefore moles of calcium nitrate that dissociated is equal to 0.75 moles, and percentage dissociation will be equal to out of 1 mole 0.75 moles dissociated. Therefore out of 100 it will be 0.75 divided by 1 into 100, that is equal to 75%. So this is the percentage dissociation or degree of ionization of calcium nitrate. (0.5% aqueous solution है KCl का. Now what is the meaning of 0.5% solution? 0.5% को हम लिख सकते हैं 0.5 divided by 100. So 0.5 हो गया weight of solute and 100 हो गया weight of solution. Therefore weight of solvent हो जाएगा weight of solution, that is 100, minus weight of solute, that is 0.5, and this is equal to 99.5 gram. अब इस solution का freezing point है 272.76 Kelvin. Now this KCl is dissolved in water. Pure water का freezing point होता है 0 डिग्री सेंटीग्रेड और 273 Kelvin. अब जब KCl डिजॉल्व कर दिया वाटर में तो उस सोल्यूशन का फ्रीजिंग पॉइंट हो गया 272.76 Kelvin. Means there is decrease in freezing point. Therefore lowering of freezing point, that is delta TF, is equal to freezing point of pure solvent, that is 273 Kelvin, minus freezing point of solution, that is 272.76 Kelvin, and this is equal to 0.24. Now calculate the want of factor. Want of factor calculate करना है, that is the value of I. Want of factor is denoted by I, and the degree of dissociation of KCl at this concentration. Kf value for water given है 1.86. Now delta TF is equal to I into Kf into M. M is the molality. अब molality की वैल्यू क्या हो जाएगी? molality की वैल्यू होती है moles of solute divided by weight of solvent in kg, and moles of solute हो जाएगा weight of solute, that is 0.5 gram, divided by molecular weight of solute. यहाँ solute क्या है? solute है KCl और KCl का molecular weight होता है 74.5. So 0.5 divided by 74.5, ये हो गया moles of solute divided by weight of solvent in kg. Solvent है water, weight of solvent है 99.5 gram और इसको kg में convert करेंगे तो weight of solvent हो जाएगा 99.5 divided by 1000 kg. ये हो गई वैल्यू मोलालिटी की. KCl का molecular weight हो जाएगा atomic weight of potassium, that is 39, plus atomic weight of chlorine, that is 35.5. 1 molecule of KCl में 1 atom of potassium and 1 atom of chlorine present है. Therefore, atomic weight of potassium plus atomic weight of chlorine will give the molecular weight of KCl, and this is equal to 74.5 gram per mole. Now, I की वैल्यू हो जाएगी डेल्टा TF डिवाइडेड बाई KF इंटू M. डेल्टा TF की वैल्यू है 0.24, KF की वैल्यू है 1.86. ये हो गई मोलालिटी की वैल्यू. सॉल्विंग I की वैल्यू आ जाएगी 1.92. नाउ KCl डिसोसिएट करता है इंटू K प्लस एंड Cl माइनस आयंस. इनिशियली अगर हम 1 मोल ऑफ KCl लेते हैं तो बिफोर डिसोसिएशन there was 1 mole of KCl and potassium ions was 0, chloride ions was also 0. But after time t, suppose x moles of KCl dissociates, तो कितना KCl बच जाएगा? रिमेनिंग KCl हो जाएगा 1 माइनस x मोल्स, मोल्स ऑफ पोटेशियम आयंस हो जाएगा x मोल्स और मोल्स ऑफ क्लोराइड आयंस हो जाएगा x मोल्स. देयरफॉर एट इक्विलिब्रियम जो सल्यूट पार्टिकल्स होंगे, टोटल सल्यूट पार्टिकल्स हो जाएगा 1 माइनस x प्लस x plus x. This is 1 minus x is the moles of remaining KCl or undissociated KCl. X is the moles of potassium ions and again x is the moles of chloride ions. X moles of KCl dissociates to form x moles of potassium ions and x moles of chloride ions. So total number of solute particles हो जाएगा 1 plus x. Now value of I is also equal to number of solute particles after dissociation डिवाइडेड बाई नंबर ऑफ सल्यूट पार्टिकल्स बिफोर डिसोसिएशन. तो ये हो गया 1 प्लस एक्स डिवाइडेड बाई 1 एंड दिस इज इक्वल टू 1.92. तो 1 प्लस एक्स इज इक्वल टू 1.92. देयरफॉर एक्स इज इक्वल टू 1.92 minus 1 and this is equal to 0.92. X is the degree of dissociation. So the value of degree of dissociation, that is x, is equal to 0.92. Weight of solute given है 60.26 gram. The solute is VCl4. Weight of solvent is 1000 gram. The solvent is CCl4. Depression in freezing point of CCl4 is 5.415 degree centigrade. Kf for CCl4 is 29.9. Now compare the number of moles of particles with the number predicted by the formula. Calculate the number of dimers V2Cl8 present. Now VCl4 associates to form dimers, means two molecules of VCl4 will form one molecule of V2Cl8. तो इनिशियली अगर 1 मोल ऑफ VCl4 प्रेजेंट था तो बिफोर एसोसिएशन मोल्स ऑफ V2Cl8 था 0. अब आउट ऑफ 1 मोल x मोल्स ऑफ VCl4 एसोसिएट कर गया टू फॉर्म x by 2 moles of V2Cl8. So after some time moles of VCl4 remaining is 1 minus x moles and moles of V2Cl8 formed is x by 2 moles. So total number of moles हो गया remaining moles of VCl4, that is 1 minus x, moles of V2Cl8 formed, that is x by 2. So 1 minus x plus x by 2 is equal to 1 minus x by 2. ये हो गया total number of moles. अब I की वैल्यू होती है number of moles after association divided by number of moles before association. तो number of moles after association है 1 minus x by 2 and number of moles before association था 1 mole. Now delta TF, that is depression in freezing point, is equal to I into KF into M. Here M is the molality. Now delta TF की वैल्यू given है क्वेश्चन में, KF की वैल्यू given है, molality की वैल्यू we can find out. Molality की वैल्यू हो जाएगी moles of solute, that is moles of VCl4 उसका फॉर्मूला होगा weight of solute that is 60.26 divided by molecular weight of solute that is the molecular weight of VCl4 and it is 193 gram per mole divided by mass of solvent in kgs. तो mass of solvent है 1000 ग्राम, इसको kgs में कन्वर्ट करेंगे तो ये हो जाएगा 1 kg. सो मोलालिटी हो गई सोल्यूशन की 0.312 मोल्स पर kg ऑफ सॉल्वेंट. नाउ I की वैल्यू हो जाएगी डेल्टा TF डिवाइडेड बाई KF इंटू M. Now putting the value of delta TF, KF and M, the value of I is 0.58. This will be 193 into 1. Now the value of I is equal to 1 minus x by 2 divided by 1. Let this be equation 1. And the value of I is also equal to 0.58. Let this be equation 2. From equation 1 and equation 2, 1 minus x by 2 divided by 1 is equal to 0.58. Solving x की value आ जाएगी 0.84. When the initial concentration of VCl4 is 1 mole, then amount of VCl4 remaining is 1 minus x moles. और जब initial number of moles of VCl4 है 0.312 moles, moles of VCl4 हो जाएगा 60.26 divided by 193 and this is equal to 0.312 moles. So when initial number of moles of VCl4 is 0.312 moles, then the VCl4 remaining is 0.312 into 1 minus x moles. So 0.312 into 1 minus x, 1 minus x मतलब हो गया 1 minus 0.84 that is 0.16. So putting the values and solving, VCl4 remaining is 0.049 moles. Now जब 1 mole of VCl4 associate किया तो moles of V2Cl8 formed is x by 2 moles. And when the initial number of moles of VCl4 is 0.312, then moles of V2Cl8 formed is 0.312 into x by 2 moles. This is equal to 0.312 into 0.42. अब x की वैल्यू है 0.84, so x by 2 की वैल्यू हो जाएगी 0.42. Solving, moles of V2Cl8 की वैल्यू हो गई 0.131 moles. जीरो पॉइंट वन एम सोल्यूशन ऑफ एसिटिक एसिड है जो कि 1.35% डिसोसिएटेड है. फ्रीजिंग पॉइंट एंड ऑस्मोटिक प्रेशर ऑफ सोल्यूशन कैलकुलेट करना है अंडर कंडीशंस ऑफ डिसोसिएशन एंड नो डिसोसिएशन. Kf फॉर वाटर गिवन है 1.86. ना परसेंटेज डिसोसिएशन गिवन है मतलब out of 100 moles of acetic acid 1.35 moles of acetic acid is dissociated. So out of 1 mole of acetic acid 1.35 divided by 100 that is 0.0135 moles of acetic acid will be dissociated. तो ये जो out of 1 mole जो भी dissociation होता है उसको बोलते हैं degree of dissociation. So degree of dissociation of acetic acid is 0.0135. Now depression in freezing point is equal to Kf into M. This is for no dissociation. Kf की वैल्यू है 1.86, M की वैल्यू है 0.1. So delta TF की वैल्यू हो जाएगी 0.186 डिग्री सेंटीग्रेड. दिस इज द डिप्रेशन इन फ्रीजिंग पॉइंट. डिप्रेशन इन फ्रीजिंग पॉइंट का फॉर्मूला होता है फ्रीजिंग पॉइंट ऑफ सॉल्वेंट, प्योर सॉल्वेंट माइनस फ्रीजिंग पॉइंट ऑफ solution. Now we know the value of depression in freezing point. Solvent is water, so freezing point of pure solvent is 0 degree centigrade. Putting the values and solving, freezing point of the solution will be equal to minus 0.186 degree centigrade. Now to calculate the freezing point of the solution when acetic acid dissociates,
then delta TF will be equal to I into KF into M. I is want of factor. The value of I in this question is 1.0135. Value of KF is 1.86 and value of M is given as 0.1. Solving delta TF is equal to 0.19 degrees centigrade and freezing point of solution will be equal to minus 0.19 degrees centigrade. Similarly, osmotic pressure of the solution for no dissociation will be equal to N by V, that is number of moles divided by volume of solution, into R into T. Now since density of water is 1 kg per liter and molality of the solution is 0.1 m, that means 0.1 moles per kg of the solvent. Now density of water is 1 kg per liter. So if weight of water is 1 kg, then volume of water is 1 liter. Now since the amount of solute present in the solution is very less, volume of solution and volume of solvent can be taken as same. So volume of solution will be equal to 1 liter. Number of moles is 0.1 moles. Putting the values and solving, osmotic pressure is 2.45 atmosphere. Now, the osmotic pressure when acetic acid dissociates will be equal to I into N by V into R into T. Here I is the want of factor. The value of want of factor is 1.0135. Number of moles per unit volume is equal to 0.1. Value of R is 0.0821 and temperature is 298 Kelvin. Solving osmotic pressure is equal to 2.48 atmospheres. Now, how to calculate want of factor? Acetic acid dissociates to give acetate and H plus ions. If initially the number of moles of acetic acid is 1 mole, then when there is no dissociation, the moles of acetate ions is 0 and moles of H plus ions is also 0. Now considering the degree of dissociation as alpha, that is out of 1 mole if alpha moles dissociates, then remaining acetic acid is 1 minus alpha moles and acetate ion formed is alpha moles and H plus ions formed is alpha moles. Total number of moles in the solution after dissociation will be 1 minus alpha plus alpha which is equal to 1 plus alpha. Since the percentage dissociation of acetic acid is given, the value of alpha, that is the degree of dissociation of acetic acid, can be calculated from the percentage dissociation and the value of alpha is equal to 0.0135. So 1 plus 0.0135 gives the value of 1 plus alpha, that is 1.0135. Now the value of I is equal to total number of moles after dissociation, that is 1 plus alpha, and total number of moles before dissociation. Total number of moles before dissociation is 1. So 1 plus alpha divided by 1 is equal to 1 plus alpha. Therefore, I is equal to 1 plus alpha, that is 1.0135 divided by 1, and this is equal to 1.0135. Now molality of the solution in this question is given as 0.1 m, which means 0.1 moles per kg of solvent. Therefore weight of water, since the solvent here is water, is 1 kg. Density of water is 1 kg per liter. Therefore volume of water will be equal to mass by density, that is 1 divided by 1, and this is equal to 1 liter. Now since amount of solute present in the solution is very less, the volume of solvent and volume of solution can be taken as same, that is 1 liter, and the molarity of the solution becomes 0.1, that is number of moles, divided by volume of solution in liters, that is 1 liter, and this is equal to 0.1 m. Therefore, while calculating osmotic pressure, the value of N by V can be taken as 0.1 and the osmotic pressure becomes equal to N by V, that is 0.1 into R into T. This is for no dissociation. And when there is dissociation, the value of osmotic pressure will be equal to I into 0.1 into R into T. 0.01 m solution of a weak base BOH in water, मतलब सॉल्वेंट हो गया वाटर, और इसका वेपर प्रेशर है, इस सॉल्यूशन का वेपर प्रेशर है 17.536 मिलीमीटर ऑफ मरकरी। Kb फॉर द बेस कैलकुलेट करना है। एक्वस टेंशन एट 20 डिग्री सेंटीग्रेड गिवन है 17.54 millimeter of mercury. Aqueous tension means vapor pressure of pure water, and this is given as 17.54 millimeter of mercury. बेस की डिसोसिएशन के लिए इक्वेशन हो जाएगी BOH dissociating into B plus and OH minus ions. Initially moles of base जो present है, let it be 1 mole and number of moles of B plus and OH minus ions is 0. Now when BOH dissociates to give B plus and OH minus ions, then out of 1 mole if alpha moles dissociate, then remaining BOH in the solution is 1 minus alpha moles. Moles of B plus ions हो गया alpha and moles of OH minus ions हो गया alpha. Now value of I is equal to number of moles after dissociation, which is equal to 1 minus alpha plus alpha plus alpha, and this is equal to 1 plus alpha divided by number of moles before dissociation. Now number of moles before dissociation है 1. So value of I becomes 1 plus alpha divided by 1. Let this be equation number 1. The value of I is also equal to observed lowering in vapor pressure divided by calculated lowering in vapor pressure. Now observed lowering in vapor pressure will be equal to vapor pressure of the pure solvent, that is water, and it is 17.540 millimeters of mercury, minus vapor pressure of the solution, which is given as 17.536 millimeters of mercury, and its value is equal to 0.004 millimeters of mercury. Now calculated lowering in vapor pressure. Calculated lowering in vapor pressure, for that we will apply the formula relative lowering in vapor pressure is equal to mole fraction of solute. Now relative lowering in vapor pressure is vapor pressure of pure solvent minus vapor pressure of solution divided by vapor pressure of pure solvent, and this is equal to mole fraction of solute. Now mole fraction of solute is equal to moles of solute divided by total number of moles. Now the molality of the solution is given as 0.01 m. 0.01 m means 0.01 moles of solute is present in 1 kg of solvent. Since the number of moles of solute is very less, we can neglect the moles of solute in the denominator. So P naught minus P divided by P naught becomes equal to moles of solute divided by moles of solvent. From this, P naught minus P, that is calculated lowering in vapor pressure, is equal to moles of solute divided by moles of solvent into vapor pressure of pure solvent. Now putting the values, moles of solute is 0.01 moles. Moles of solvent will be equal to weight of solvent, that is 1000 grams. 1 kg is equal to 1000 grams divided by molecular weight of solvent, that is 18, since the solvent is water, into P naught. P naught is given as 17.54, which is the vapor pressure of pure solvent, which in this case is water. Solving, the calculated lowering in vapor pressure is equal to 0.00316 millimeters of mercury. So value of I becomes equal to 1 plus alpha divided by 1, which is also equal to 0.004 divided by 0.00316, and this is equal to 1.266. From this, 1 plus alpha is equal to 1.266 and alpha is equal to 0.266. Alpha will be equal to 1.266 minus 1, that is 0.266. Kb is equal to concentration of B plus ions into concentration of OH minus ions divided by concentration of remaining BOH. Now, when the initial concentration of BOH was 1 mole, then out of 1 mole alpha moles dissociated and concentration of B plus ions was alpha moles, OH minus ions was alpha moles, and the concentration of remaining BOH was 1 minus alpha moles. But in the question it is given that the initial concentration of BOH is 0.01 m, which means the number of moles of BOH present in the solution is 0.01 moles. So when the initial concentration of BOH is 1 mole, the concentration of B plus and OH minus ions is alpha moles, and when the initial concentration of BOH is 0.01 moles, then the concentration of B plus ions will be 0.01 into alpha, OH minus ions will be 0.01 into alpha, and the remaining BOH will be 0.01 into 1 minus alpha. Now value of Kb is equal to B plus ion concentration into OH minus ion concentration divided by concentration of remaining BOH. So putting the values, we get 0.01 into alpha into 0.01 into alpha divided by 0.01 into 1 minus alpha. Solving, the value of Kb is equal to alpha square into 0.01 divided by 1 minus alpha. Now putting the value of alpha and solving, the value of Kb is 9.6 into 10 to the power minus 4. In an Oswald-Walker experiment, dry air was first blown through a solution containing certain amount of solute. Molecular weight of solute given है 278 in 150 gram of water. Solvent है water और weight of water given है 150 gram. And then also through pure water. The loss in mass of water was found to be 0.0827 gram, while the mass of water absorbed in sulfuric acid was 3.317 gram. Calculate the amount of the solute. For Oswald-Walker experiment, there is a formula. Loss in weight of the solvent. Loss in weight of the solvent is directly proportional to vapor pressure of pure solvent minus vapor pressure of solution, and total loss in weight or mass of water absorbed by sulfuric acid will be equal to vapor pressure of pure solvent. So if we take the ratio loss in weight of the solvent divided by total loss in weight or mass of water absorbed by sulfuric acid, we get the ratio lowering in vapor pressure divided by vapor pressure of pure solvent, and this is known as relative lowering of vapor pressure, and this is equal to mole fraction of solute. Mole fraction of solute is moles of solute divided by total number of moles. Total number of moles will be equal to moles of solute plus moles of solvent. Now here the solvent is water. Weight of water is given as 150 gram. So moles of water or moles of solvent will be equal to 150 divided by 18. Now since the amount of solute is very less, moles of solute is neglected in the denominator. And in the numerator, the moles of solute can be written as weight of solute, which is denoted by W, divided by molecular weight of solute, that is 278. And this is equal to 0.0827, that is loss in weight of the solvent, divided by total loss in weight or mass of water absorbed by sulfuric acid, that is 3.317 gram. Solving, the weight of solute is 57.7 gram.